Can you control whether it's on or off?
Yes. So we'll wait for him to.
Just give it to him right now.
Okay. Turn down channel 1 to 0. Turn down microphone 1 to 0.
Take your seats. We're about to begin. I hope can you all hear me clearly? Okay. I'm Ron Salk. I'm on the board of the League of Women Voters, and for the past 5 years, I've been involved with chairing the symposium. So I promise that I'll only speak a few minutes. That's one of the privileges. I remember 5 years ago, 38 people showed up at our meeting of the League of Women Voters on a Saturday morning. We were discussing water conservancy. Over the years, the focus has changed completely. Now we're talking about water inundation, sea level rise, and so forth. And it's encouraging that this is the largest single audience that we've had respond to a national emergency. This is the national emergency. The science can't even keep up with it all, as you'll hear today. And that's one of the reasons you're here, to get the latest information. The New York Times and others reported on Thursday that the science is running 40% under on the estimates for sea level rise and global warming. Our speakers today are going to try to clarify that. I'm allowed one bromide. The bromide is the journey of 1,000 miles begins with a single step. It's always the same step, but we have to take it. Consumer awareness is that step, and that's why you're here today. And I want to welcome you and turn you over to some of the best experts in the field. And so with that, Kim Ritter, President of the League of Women Voters, will address you for a few minutes.
Well, good afternoon and welcome, everyone. My name is Kimberly Ritter, and I'm the president of the Long Beach Area League of Women Voters. I want to thank you all for joining us here today at the beautiful Aquarium of the Pacific for our 5th annual Climate Change Symposium. The League began in 1920 as a mighty political experiment designed to help 20 million American women carry out their new responsibilities as voters. It encouraged them to use their new power to participate in public policy, and from the beginning, the League has been an activist, grassroots organization whose leaders believe that citizens should play a critical role in shaping policy. The League of Women Voters, we are political, but we are nonpartisan, and what I mean by that is that we never endorse political parties or candidates, but we do advocate for various public policy issues, and the issue of climate change being first and foremost on the agenda today. Now, the League has a dual mandate, voter education and advocacy, and our goal today is to fulfill both parts of that mission. Our program this afternoon, that covers the education part. We have an amazing lineup of speakers that I suspect you're already a very knowledgeable audience, but you'll leave here even better informed about the science and impacts of climate change. Fulfilling the second part of our mission, that will depend on your actions when you go out that door today. And I'm talking now about advocacy. Climate change is here, it is real, and we're already feeling the impacts in our communities. Extreme heat, drought, coastal surge, and sea level rise. A recent article in the New York Times reported that America's carbon dioxide emissions rose by 3.4% in 2018. That was the biggest increase in 8 years. And this occurred even as a near record number of coal plants around the United States have been retired. The problem is we have not yet decoupled U.S. economic growth from emissions. That same article linked to a list of 78 environmental rules that the administration in Washington is seeking to do away with. And many of those rules would have had a direct impact on our ability to reduce emissions. We do not have time for climate change deniers. The time to press on is now. We ask that you contact your legislators and demand action. And most importantly, vote. Remember that your vote is your voice, and it is the single most important tool that we have as citizens to create change. I am now honored to introduce our speakers and thank them for coming out here on a Sunday afternoon to share their expertise and insights with us. First, we have Dr. Jerry Schubel, President, CEO of the Aquarium of the Pacific. Dr. Lynn Talley, Professor of Physical Oceanography, Scripps Institution of Oceanography. Dr. Bill Patzert, climatologist and oceanographer from NASA's Jet Propulsion Laboratory, recently retired. And Dr. Holly Jean Buck, Research Fellow, UCLA Institute of the Environment and Sustainability. And finally, before we begin today's program, I would like to thank the League of Women Voters members who helped to organize and put on today's event. First, Organizing Chair Ron Salk, Publicity and Media Relations Iris Yokoi, Social Media Lisa Andrea, and Jan Gallup, who along with Lisa and Iris assisted in checking in our guests today. And of course, we owe a huge debt of gratitude to the aquarium staff who dedicated many hours to making today's event a success. Among them, Linda Brown, Adina Metz, Marilyn Padilla, Dave Bader, and many others. I'm now very pleased to begin our program by welcoming Dr. Jerry Schubel to the stage.
Thank you, Kim, and welcome all of you. It's good to have you here this afternoon. I want to draw your attention to that quote at the bottom of the slide. Doubt is not a pleasant condition, but certainty is absurd. How many of you here believe that climate change is happening? Raise your hands. I can see. Pretty good. How many of you believe that humans are the major driver? Not all of you, but still a large percentage. So, I changed my whole approach to this talk based upon two things. So Ron doesn't even know this. But flying back from Christmas on the end of December, I sat across from two well-dressed gentlemen on an airplane on the other side of the aisle. First of all, having two well-dressed gentlemen on any airplane is unusual in this day and age. And secondly, one was trying to convince the other, and they obviously didn't know each other, that climate change was real, the science was clear, and that humans were a factor. The other thing that led to my changing of my approach is that I had listened to the December 30 program of Meet the Press, a 1-hour program devoted entirely to climate change. And it wasn't a particularly good program, but the slide that's up now is one they showed. It was a survey that CBS did with a number of other organizations. And I think it's very clear that this should be of interest to anyone who votes, and particularly to the League of Women Voters. There's a lot of work to do. It's not uniform across parties, certainly, but there's a lot of work to do. And the question was, what's the percentage of people by political party who believe that human-caused climate change is proven scientifically? Now, first of all, science is not a belief system, or not entirely a belief system. Science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and hypotheses and predictions about the natural world. Ptolemy, who is a Greek mathematician and astronomer and philosopher, once remarked, "The role of the scientist is to tell the most plausible story that saves the facts." Scientists will challenge any story. A scientist likes nothing better than to prove another scientist wrong. That's how you get promoted and tenured, and you get well known. So when a story survives and it gathers support among experts, particularly among those in that field of expertise, it grows in robustness. And so with climate change being endorsed by huge numbers of climate scientists, that's when belief does appropriately weigh in. Now, there are many parts of the climate story that are still poorly understood. But the underlying story, the plot of that story, is very clear and scientifically unambiguous. So science is not a faith-based system, but once it's well established, it can become a belief system. So let me review some of the facts for you. Temperature is increasing globally, no question about it. 2018 was the fourth warmest year on record. The other three warmest years were 2015, 16, and 17. And if you look at the annual average, the black with the blue dots, everything is going up. And if you can't see that increase, I have a very good ophthalmologist I would like to recommend to you. And here is another, the global temperature index, the annual mean and the 5-year mean. And again, this comes from NASA, and their data show that the average global temperature has increased by about a degree Celsius, so about almost over 2 degrees Fahrenheit since 1880. And 2/3 of that increase in the Earth's average temperature has happened since 1975. The world ocean has absorbed about more than 90% of all of the energy that the Earth has received since the Industrial Revolution. And the world ocean has risen in its average temperature by about 1/10 of a degree Celsius, so about 2/10 of a degree Fahrenheit above what it was 50 years ago. And some of you may say that's not very much, but it is a lot when you think of the mass of the ocean and the specific heat of water. Specific heat, to remind you of your 7th grade science, is the amount of heat you have to add to raise the temperature. So the number of calories per gram of 1 degree Celsius. And water has the highest specific heat of any liquid except liquid ammonia. And as a result of this warming, we've seen the loss of about 20% of our coral reefs. We see fish migrating north and south to stay into their preferred temperature regimes. We see storms intensifying. And in an article in Science magazine last week, the point was made that the ocean is warming 40% more rapidly than had been predicted by the UN just 5 years ago. So if you look at the facts, pretend you're Ptolemy, it's clear that the Earth's average temperature is increasing. Those facts are indisputable. Sea level is rising. Sea level is rising more rapidly than at any time in the past 7,000 to 8,000 years. Coastal flooding is more frequent, and we have with increasing frequency what is called sunny day flooding. And if you look at that curve, that goes back to the end of the Ice Age, showing that about 18,000 years ago, sea level began to rise rapidly. It rose rapidly until 7,000 or 8,000 years ago when it slowed down, and for the next 7,000 to 8,000 years, it was stable. And it was during that period that most coastal settlements around this country and around the world took place. It looked like being close to the ocean was a good place to be, because you had all the benefits of the ocean, and the ocean seemed to be well behaved. But in the last 100 to 150 years, sea level has taken off, and if you just look at this curve, you can see what's happening. And sea level is a powerful indicator of warming. When you warm any liquid, it expands, and the ocean is no exception. And when you warm the Earth, ice on land melts, and that meltwater goes to the ocean and adds to it, and that also causes sea level to rise. Now, these are predictions of what sea level might look like all the way out to 2100. And that's a pretty big range of uncertainty. And so this is one of those areas where the science is not settled. It's also not settled how much is temperature going to rise and how rapidly. The direction of these signals is clear. The magnitude is much less clear. I think right now all the data would suggest we're going to be at near the upper range rather than near the lower range. So sea level continues to rise, and it rises at an accelerated rate. And much of the future is going to depend upon what happens in Iceland, that should be in Greenland, and in the Antarctic. If all of the ice on Greenland were to melt, sea level would go up about 20 feet. If all of the ice of Antarctica were to melt, it would go up about 200 feet. Now, that would take thousands of years, so it's not going to happen right away. But it has happened in the past. So we need to keep our eye on what's happening there. And in both cases, ice is melting more rapidly than has been predicted by the IPCC just a few years ago. These are the extreme weather-related events that each one cost more than $1 billion in 2017. And the point is that extreme weather events are increasing in intensity and in frequency, and they include heat waves, droughts, wildfires, and just look what happened to California last year. Floods and tropical storms. In 2018, we had 15 named storms, including 8 hurricanes, of which 2 were major storms. That is, they were category 3, 4, or 5. While no single extreme weather-related event can be attributed to climate change, it's very clear that the probability of these events goes up with warming. The warmer the Earth, the greater the probability we will have these events. So, 90% of the heat added to the Earth since the Industrial Revolution has gone into the ocean. For the last 102 years, all right. For the last 102 years, scientists at the Scripps Institution of Oceanography have walked out to the end of Scripps Pier and measured the temperature. And in August of 2018, they measured the highest temperature they had ever measured in 102 years. And it was almost 80 degrees Fahrenheit. Now, later you're going to hear from Bill Patzert. Bill got his PhD from Scripps. I think he may have been the first one 102 years ago to walk out to the end of the pier. But Bill will tell us that. So in the summer of 2018, for 85 straight days, air quality in the LA basin fell below federal air quality standards. And in July, ozone levels violated health standards on all days except one, the 31st of July. The ocean is getting more acidic. Scientists estimate that about 30% of the CO2 added to the atmosphere since the Industrial Revolution, only 30%, has been transferred to the ocean, and that has increased the acidity of the ocean. That is, it has lowered the pH by about 30%. So, without ascribing cause, if you were Ptolemy, what is the most plausible story that saves the facts, that is consistent with the facts? I think you have to conclude that Earth is warming, Earth's climate is changing, and yes, it has happened before in Earth's history, but never in the 200,000 years that human beings, modern humans, have been around on this planet. So what's different? It has never changed this rapidly in any record that we have. What's causing it? Well, let's look at the facts. The levels of heat-trapping gases in the atmosphere, particularly CO2, are increasing dramatically. This is the famous Keeling curve, and CO2 levels are up by more than 250% since the Industrial Revolution. And if you look back through geologic time, starting here in the present, here we are, there's today, go back 400,000 years. Remember, humans, modern humans, first arrived 200,000 years ago. We have never had a CO2 level in the atmosphere as high today as we have today in that 400,000 years ago. So who's doing it? Population. We are. There's a case that if you look at the purple curve, that's a projected population curve. The green part is in the developed countries, and the purple part, that's the total population. So you can see that the most of the population growth is occurring in the undeveloped or the developing world. And here, this is the record of primary energy use starting back 1750 and going forward. And again, you can see the dramatic increase in primary energy use associated with the growing population. And you have to remember that today, still, more than 80% of our energy comes from fossil fuels. It's true that the percentages coming from wind and solar are increasing dramatically. But the percentages that we start with are so small, they just don't scale up quickly enough. This is another key, giving young women an opportunity for an education. This is probably the single most important key to stabilizing and then reducing population. And 50% of all girls today under the age of 10 live in countries with severe gender inequity. That's a problem we all should be concerned about. Now, all of this happened before, not within the last 200,000 years of modern human history. It was in the Pliocene. The Pliocene is a geologic epoch that took place between 3 and 5 million years ago. Our earliest ancestors, Neanderthals, all the ones that came before modern humans, they go back 4 to 4.5 billion years. So they probably experienced part of the Pliocene. And in the Pliocene, CO2 levels were 2 to 2.5 times higher than today. Average Earth temperature was 5 to 7 degrees Fahrenheit, 5 to 7 degrees Fahrenheit warmer than today. And sea level was as much as 130 feet higher than today. And all of that was attributed to extensive volcanism that was taking place around the planet. So it has happened before. There was a very important article in Nature magazine on the 5th of December, and 3 distinguished scientists estimate that things are going to happen much more quickly for 3 reasons than we've been led to believe. First of all, greenhouse gas emissions are still rising. Air quality is improving. Now that sounds strange, but if air quality improves in the upper atmosphere, you have fewer particulates, more solar radiation can make it to the Earth's surface and get absorbed and re-radiated, and that has happened. And finally, we're entering a warm period of the Pacific decadal oscillation. So because of those 3 factors, they estimated that the 1.5 degrees Celsius warming, which was, remember, that was the goal that came out of Paris. They estimated that would move up from 2040 to 2030. That's not very far from now. 2019, that's only 11 years from now. And they estimated that the 2 degrees Celsius boundary, the one that was the caution raised in Paris, would move up to 2045. That's only 26 years from now. And they pointed out that it could happen even sooner. And they also suggested with this more rapid warming, estimates for sea level rise would also go up. And they put it at 2 to 3 feet higher by 2050, and 7 to 10 feet higher by 2100, or even more depending upon what happens to Greenland and to Antarctica. So, can we slow global warming? Can we stop it? Can we even reverse it? Yes, we can slow it by reducing the amount of greenhouse gases in the atmosphere, and the best way to do that is by reducing emissions. And the most effective way to do that is to reduce our reliance on fossil fuels. Remember I said 80% of all energy used globally comes from fossil fuels. And even last week, the president of France announced that he intended to retire 23 of their nuclear plants and replace them with natural gas. That's not a good move. Emissions in 2017 and in 2018 actually increased rather than decreased following COP21 in Paris. And in 2018, you've already heard our emissions in the United States went up by 3.4% after having gone down the previous 3 years. Many of the same people that were in Paris got together in Poland in December to develop a rule book to enforce these commitments made in Paris. But there's still no teeth. There are no consequences for not complying with the commitments. So yes, we can slow climate change, but it will be challenging. And I think we also have to include not just the energy that we use to generate electricity, we've got to bring agriculture in and transportation because they're both key. Can we stop it? This is very unlikely. There's a very large inventory of heat-trapping gases already in the atmosphere, and they tend to stay there for a long time before they get transferred to the ocean. Only about 30% of the emissions added since the industrial age have been transferred to the ocean, and as the ocean warms, the solubility of CO2 in the ocean goes down. Once you put CO2 in the atmosphere, roughly 50% of it stays for decades, 30% stays for centuries, and 20% stays for millennia. So the heat-trapping gases that are already in the atmosphere are going to last a long time. This means that our past practices have committed us and our descendants to continued warming, fueling continued climate change, and all the things that go with climate change, sea level rise, extreme weather events. So, can we stop it? Not for a very long time, even if we dramatically reduce greenhouse gas emissions. So what do? Does that mean we shouldn't dramatically and drastically reduce our greenhouse gas emissions? By no means. There's lots we should do. While keeping the warming to below 1.5 degrees Celsius to me seems impossible, and keeping it to even 2 degrees Celsius, it will be a major challenge unless we can intentionally remove CO2 from the atmosphere and lock it away safely. And Holly is going to talk to you later about that. Now, some people call that geoengineering. I think you could easily refer to it as a pollution problem we've created over the last 200 years, and now we've decided we're going to figure out how to clean it up. So what are some of the things that we can do? Well, we should listen to what the science says. We should keep an open mind to all options. We should continue to move to renewables. We should not write off nuclear. It's still the highest energy density source we have. It's the cleanest. And if those of you who get the Wall Street Journal, I highly recommend an article in Saturday's Wall Street Journal about nuclear and comparing its safety to other forms of energy. It's worth reading. Support research on geoengineering, just in case. It would be too bad if we got to the point of no return and we had not invested in that research. Focus on transportation and agriculture, particularly livestock. Livestock are a big contributor to climate change, and they also drink a heck of a lot of water, 20 to 25 gallons per cow. Does California really need 5 million cattle? I don't think so. And we need to adapt, because sea level is rising. It's going to continue to rise. We're going to have more hot days. We're going to have less water in Southern California because we get more than half of our water from imports from Northern California and from the Colorado, and both of those imports will go down with climate change. We need to transform agriculture. If we're going to remain the largest agricultural economy in the United States, we have to start shifting to crops that are more thermally tolerant. New species, whether they're genetically modified or not, but at least different varieties of the same species. And why should we be devoting 1 million acres, last year, 1 million acres to grow alfalfa, which is a water-thirsty crop? We exported most of that to China to feed cattle, which contribute to the problem. And I think we need to support offshore aquaculture. You can grow a better, healthier source of protein in the ocean. It doesn't contribute to climate change. It doesn't take any fresh water or any land, and we'd all be better. So what's the most plausible story then that saves the facts? I ask you, Mr. Ptolemy, all of you out there, I think that the only conclusion that one can draw is that we are living in the Anthropocene. Now, that has not been officially accepted by the international group that approves on a new geologic epoch, but this is the geologic epoch in which humans have modified the Earth's climate and are continuing to modify the Earth's climate and its processes and phenomena. And the frightening thing is, we're going to live in the Anthropocene for as long as there are humans on this planet. So we better figure out how to do it. We need to use all the creativity and innovation that got us into this situation and figure out ways to live in greater harmony with the Earth in the Anthropocene. Again, we have to keep up open minds and be open to all options, including nuclear energy and at least certain kinds of geoengineering. This is a very famous guy who used to live in Baltimore, H.L. Mencken. He was called the Bard of Baltimore. He had a lot of wonderful pithy phrases. I love this one. For every human situation, there is a simple solution, neat, plausible, and wrong. And I think he's right. The problems we're dealing with today are what are called wicked problems. They are transdisciplinary in nature. They don't fall within any discipline. They don't have any silver bullets, no single solutions. If we formulate them properly, you can manage them. You can't solve them, but you can manage them to keep them within bounds. And if you do it properly, then the goal should be what the RAND Corporation states as to minimize regret. That's a pretty high bar. That may seem like a low bar to minimize regret, but project yourself into the future 20, 30 years and look back at what the situation is. Have we minimized regret? So, you can lead a human to knowledge, but you can't make him think. Thank you.
Hello, woo, the complete lights. I'm Lynn Talley, I'm from Scripps. Mike, oh, Mike on? I have no lapel. I do need a mic. How's a mic, where do I get a mic? Use this mic. This one's okay. They said there's some kind of recording going on, so I could scream, but maybe that's not the best idea. Scream at my kids. No. So I did try. Our family's trying. We live in La Jolla, and we put in solar, so our house is kind of generating electricity back. Our town is doing a great job of making that work. SDG is begrudgingly allowing it. And then we traded in our used electric car, which was extremely range limited. I wouldn't even drive it myself, 30 miles. And I drove up in our brand new American-made Chevy Bolt today. And I got a really great parking spot because I did that. The parking lot was full except for that space. So we're trying to go, as a family, energy-free. Fossil fuel-free as much as we can. So my topic, I'm an oceanographer. I've been there at Scripps for a long time. And I've been working on climate as an outgrowth of what I do. My own job is working on large-scale circulation, large-scale ocean properties. And then that naturally gets you involved in the climate business. So I'm going to show you some stuff about what's been going on in the ocean, and you've already seen a lot of it. I'll probably be a lot more down in the weeds on some details. How do I make this thing work? You told me already. That's it. Ooh, I touched that. Okay, this is a wonderful NASA website. Thank you, NASA. Where are you, Bill? What? It is still up. the federal government is shut down. There's kind of a ban on climate stuff, and this site is trucking, and that red dot there at the top of the curve blinks at you when you go on the website and shows you what the temperature is today. So you've already seen this temperature record or something like it. There it is. It's going up. They give you a nice number that they calculate every day, presumably, and we're now at 0.9 degrees C above about 30, 40 years ago. On there, and that keeps on going up. You see a little ledge in it a few years back. That was when it flattened out, and that was great glee for the climate skeptics out there. That was called the hiatus. How many people have heard of the hiatus? Yeah, it's not a hernia, it's a hiatus. There was some, maybe it's stopped. Well, this is the global surface air temperature. This is not the heat in the system, and you've already seen what's going on with the heat. So we'll move on quickly. On the same website, this is a great little animated thing you can scroll from 1884, limited data, but you can get up to into the 2000s, and there 2017, and see that actually the change in surface temperature is not uniform. Where is it warmest? Warm the most? In the Arctic, in the polar regions. It's already 2 degrees Celsius up there. Yeah, well, Santa's workshop is turning into Florida. A lot of ice is melting off, and that has significant consequences for the planet. There are some interesting blue holes in the North Atlantic, and that's due to a change in the circulation, actually, that's due to warming, it turns out. Anyway, there's some stuff going on, and here's the New York Times just a couple days ago. Probably a lot of you saw this article. It's a beautiful photo showing coral reef, sort of somehow they photoshopped this or something, and in the tropics. Coral reefs are definitely a victim of warming and acidification together, mostly warming at this point. Ocean warming accelerating faster than thought. The article that they're referring to is something new in science. This does not work. How do I do this? How do I get to, it slowly shows up. It's an article in Science that came out a couple of just last week. There are several new ones out. This one actually kind of replaced one that was based on a much more speculative method. This is based just on data. There you see the floats going in. These things were invented at Scripps. They now populate the world ocean, 4,000 of them, and these are our best record for the upper 2,000 meters of the ocean. This article summarizes several different articles. There's some, I don't know how to get this to go. Ooh, there it comes in. A mind-numbing graph, but this is mostly from the IPCC. You've heard about it already, the Intergovernmental Panel on Climate Change. I was a member of one of the lead authors on that for the last 2 go-rounds, starting 2007 through 2013. And I want to put in a plug for IPCC. They're getting a lot of bad press now because we underpredicted. The reason we underpredicted is because IPCC is, by definition, the most conservative document there is. It's the most reviewed, the most synthesized, the most carefully, I would say, I've never been in a process with that much review. It's very carefully put together, packed with facts, and then the groups involved assess certainty and uncertainty, and they have this arcane language for doing that, but everything that you put out there should have a certainty attached to it. And if we're not sure, I was in a panel on ocean observations 2 times around, 2 committees. If you're not sure, then you publish the more conservative with the larger error bars. And so I'm not surprised that it's actually warming faster, but it is warming faster just the last measurement period. It's accelerating. And several of the lead authors in the same chapter as part of are authors on papers that say it's accelerating. It definitely is doing that. And this isn't anything new in the news. Let me see if I don't know how to get this to work. I'm not young enough. Okay. There we go. The kids can do this. Back in 2016, there was, the 2015 is the warmest year on record. This is nicely cited back through that New York Times article. So there's a map down at the bottom showing the warming over many. It's a temperature anomaly. The IPCC, which I just mentioned, is part of the UN Environmental Program. UN has the Framework and Climate Convention over here, which is doing that meeting that was in Prague just now, the Paris meeting, back through Kyoto. Every year they've got that. That's where they put together the policy response. On this side, we have the Intergovernmental Panel on Climate Change, which synthesizes science and engineering. And so that is meant to be that is the information that feeds into the policy making. So this is their most recent report, Global Warming of 1.5 C. I recommend it if you're interested in getting in, and all you have to read is the summary statements, and it's kind of fun to really see what is happening out there. I can't, what am I doing? My clicker, this thing. I shouldn't be touching that screen. I shouldn't touch that screen. No, that went back. That went the wrong way. Okay. Well, there we are. This is one of their statements. This actually says something about global warming is likely to reach to 1.5 degrees C between 2030 and 2052. There's the conservative statement, and now we're saying 2030. Talking a bit, so most of what I'm going to show from here on through is from the IPCC. It skipped too far. That's all right. These are the headline statements from the 2013-14 IPCC. Number one doesn't sound very scientific, but it is. It's based on about 12 inches of documents of fine font synthesis of everything. Warming of the climate system is unequivocal. There's no doubt. Human influence is clear. Continued greenhouse gas emissions will cause further warming. Limiting climate change will require substantial, sustained reductions of greenhouse gas emissions. Each of those is backed up by hundreds of pages. Is this going to work? No. What am I doing wrong? I'm not following directions very well.
Just get it way back. So get it away. Just
Don't let that, you had no problem with this. Thank you. Okay. So why do we have climate change? Summary statements. You already heard it. You already know it. But these are, the actual language. Anthropogenic greenhouse gas emissions have been the dominant cause of observed warming since the mid-20th century. The largest contribution is increase in the atmospheric concentration of CO2 since 1750. This is important. There are a lot of greenhouse gases. There are a lot of things that are like the aerosols, the air quality stuff, that actually make it cooler. The reason it's warming is dominantly CO2. The way we fix it is dominantly through CO2. Let's see if I can make this work. Hold it back. No. Over here. You did it. How did you do that? There it is. Okay, what is the greenhouse effect? I'm not going through this diagram. If you're really interested, there's lots of them online. Just go find it. It's great. Sun comes in, it reflects back off of stuff. It goes all the way, some of it gets all the way to the ocean, gets to the land surfaces, comes back up as long wave radiation. We are all radiating because we are not 0 degrees Kelvin. We radiate energy back, and that gets caught in the atmosphere and may radiate back out again in all directions, and that all makes kind of a nice blanket. And that blanket depends on what's in the blanket. And the more CO2, and we have a stable temperature, we have more or less over the eons that we live in. We love greenhouse effect, but if you perturb that with greenhouse gases, then you've added more stuff that does more of that radiation and keeps more of the heat in. That's simple, and 100 and some years ago, they predicted on the back of an envelope what the warming would be in response to the amount of CO2. And that back of the envelope is borne out by all of the most complicated models and measurements and everything since then. There's nothing difficult about this. Let's see, we'll try to go to the next one. Yes. It did it. You've seen the Keeling curve. I got a bigger number because I pulled it off 2 days ago. It's now at 411. There's Dave Keeling down at the bottom, very persistent, very dogged, very on it since 1957. That was the year of, what happened in 57? Sputnik. That's why I got a good education. Sputnik. It was the IGY, the International Geophysical Year. Part of that was Sputnik. Part of that was going out and starting to measure things like this about the planet. Dave went off to Mauna Loa and said, let's set up a station. And miraculously, well, he knew this, the atmosphere is well enough mixed that that measurement at that one point way up high in the atmosphere in the middle of the Pacific is representative of the whole northern hemisphere pretty well. So there it is. There's the curve. That's what we like to track. You can go on the Scripps website. There it is. And the jiggity-jaggedy stuff is the northern hemisphere breathing, winter and summer, winter and summer. Photosynthesizing and then decaying. So you can go and visit that if you go to Hawaii. It's fun. And it's not quite as high as the telescopes where you can't breathe on the other peak across the way. And then you've also seen this. And this is where these data come from. This is the 800,000-year record. Here we are now. This comes from ice bubbles in ice cores that are drilled out of Antarctica and Greenland. And my husband works on this. So these are pictures from him. There's some bubbles. Okay, what does it do? I've highlighted in red what greenhouse gases do to the ocean. We warm the ocean, we get acidification. Oh, why? We put more CO2 in the atmosphere, it goes into the ocean. Great, service. Ocean took up 30%, great. But you put CO2 in water, what does it do? It becomes more acidic. You can tell that just with a piece of litmus paper and a little cup, and you blow some air into the cup out of your own lungs with CO2 in them, because you've just been doing respiration, and you look at the and when it got more acidic. There it is. Weathering happens because there's CO2 in rain drops. So it's carbonic acid. There it is. So we also acidify. We have big changes in rain, drought and floods that are coming with this global warming. And that's actually a very, very important thing to look at, not just the global warming temperatures. And you have already seen some slides about that. Most of the ocean is 70% of the Earth's surface. When it rains a lot, the ocean surface gets fresher. When it evaporates a lot, it gets saltier. We've been measuring salinity for many, many decades, just like we've been measuring temperature. So salinity is our global rain gauge. It's lovely. It's showing us what's happening. Sea level rise, et cetera. What do we know about the oceans? Ocean warming dominates the increase in energy. 93% of it's in the ocean. The ocean has absorbed about 30% of emitted anthropogenic carbon dioxide, causing acidification. Human influence has been detected in warming of the atmosphere and the ocean and in changes of global water cycle. And salinity is one of the records we use to see that. And finally, heat will penetrate from the surface to the deep ocean and affect ocean circulation. We should change that statement. It should say heat has penetrated from the surface to the deep ocean, and I'll show you that. And it is affecting ocean circulation. More arcane things. IPCC, I explained, AR5, Assessment Report 5, so that was the fifth one. The Assessment Report 6 is currently underway. Working Group 1 is physical science. And this is we're going to talk about carbon first. Here's carbon. Yes. Okay, this is the other CO2 problem. Carbon dioxide goes into the water, and the excess acid has an effect on things like shells, bones, fish bones. It has an effect on coral. Coral is affected both by this and by the rising temperatures, and it's occurring now. It's having an impact, and it has had demonstrable impacts along the West Coast, especially in the Pacific Northwest. On the shellfish fisheries there is a large ocean acidification effort going on the entire west coast of the U.S. and Canada to monitor with the little alarms that your water going into your oyster tanks is a little acidic, turn it off. So this is actually an effect of carbon dioxide. So there's a model projection in the IPCC to show that ocean pH overall will be lower at the end of the century. And that has a lot of spatial pattern to it that I won't get into. High latitudes are affected more seriously than low. Okay, to heat. This is what I work on more. Oceans and heat. Ocean warming dominates the increase in energy stored in the climate system, more than 90%, and our number is usually 93% that we toss around, between 1971 and 2010. Why that odd year, 1971? Satellites went up. We started really being able to monitor things globally. It really changed the quality of the data set, so we like to use that as a reference year. And starting in the 1990s and then really coming in the 2000s was this new technique of quote-unquote Argo. Profiling floats, there's a float there. There's the map just a few days ago showing all the profiles for the last, in that time period, the last month. There are 4,000 floats out there. They just celebrated the 2 millionth profile since about 2004. This is our weather system for measuring the upper ocean. This has completely transformed oceanography. Just from an oceanography standpoint, our graduate students don't know that measurements existed before this. They're reinventing everything using this amazing data set. So using this amazing data set is what led to that paper that we showed that was highlighted in the New York Times. Using all this stuff, and I can't get this to go. This is the IPCC's map. A few years ago, the maps are getting better all the time. This shows the heat increase, heat content, how much heat there is in the top 700 meters since 1950. So this is harking back to data sets that were available before these floats. So here, in the upper 700 meters, it's a 0.3 degree C increase. What you saw on that map at the beginning was it's up to 2 degrees in some places of the surface temperature, and that's the ocean. So this has some nice patterns, and as oceanographers, we get very excited about them, but we won't talk about them too much here. There's a lot of red. That's what you need to notice. There are places where it's redder than others. There's places where it's kind of noisy. But this is the upper ocean. You see warming pretty much everywhere. Tends to be more heat absorbed overall in the Southern Ocean, where there's that huge Antarctic ice sheet, and in the North Atlantic, where Greenland is nearby, for various oceanographic reasons. Now, we also measure the deep ocean. And we go out periodically every 5 to 10 years on that grid of lines in ships. I'm in the middle of that picture. I'm doing one piece of one of those sections. I've spent a lot of time on these things. These take a couple months. We have a lot of people. We measure a whole lot of things, including all the this is where the carbon information comes from for the ocean globally. And we make these measurements. And this is part of the Global Ocean Observing System. And this is a map used, heavily cited now at this point by, it was a graduate student PhD thesis at the University of Washington, Sarah Perkey, who's now a faculty member at Scripps, with Greg Johnson, who was her advisor, showing that the deep ocean warming is not uniform. It's got this really oceanographically interesting signal. It's really in the Southern Ocean. So a lot of us are working hard on understanding that. There's a whole lot of connection from the surface of the ocean to the bottom all around Antarctica. Warm water comes south, it gets, there's ice, and it gets cold, and it goes down. And if you've got changes in the upper ocean conditions, you'll see them down there faster. So this is a really eye-opening map. All that gets synthesized in the next slide. Why am I having trouble with this? There. There's a chart, a graph. My glasses. Back to the 50s. The upper ocean, okay, this is from left to right is time increasing. This is a vertical axis and some unit of energy that's in the ocean. This is heat energy. It's in zettajoules. There's a unit to look up. Quiz yourself on the zettajoule. Anyway, what's important is everything's on the same graph. That upper ocean is that light blue wedge. The top of that light blue wedge is the total heat content of the entire system of the whole Earth, including all parts. And if we can move to the next little piece of this, there's the deep ocean map. So the deep ocean is that dark blue. About 20% of the energy has gone into the deep ocean. And tail wagging the dog, there's the atmosphere in a little wedge of purple at the bottom you can't even see. We live in a gas. Gas doesn't hold much heat. We care about the temperature change of it. We are really lucky the ocean is out there to absorb so much of the excess energy that we're putting in. So it's a very small part. Hence, the energy is being partitioned between the two. It's dynamic. So the hiatus thing of the global surface temperature a few years ago was merely a matter of the energy hiding in the ocean. It was all there, and you can see that here. That light blue top graph thing has no hiatus, and this is well measured, and it's just trucking along. And so that's what you're seeing now nicely in the news, saying that global warming is ocean warming. That's warming. I'm going on way too long. We want to hear about water, though. We live in California. We've had an awful lot of drought. Not the last few weeks. Not yesterday, during the soccer games. But what's going on? Well, the IPCC says the changes in the global water cycle in response to warming will not be uniform, not spatially uniform. What does that mean? Actually, what it means is that wet gets wetter and dry gets drier in overall. And how many people have heard that statement? Maybe some of you have heard that. Wet gets wetter, dry gets drier. The rich get richer, the poor get poorer. But maybe you don't want to be all that wet. Maybe you don't want to dry out. The boundaries shift a bit. Locally, there's spatial structure to it, but this is the overall pattern. Why? Oh, because the atmosphere is warmer. It got warmer, and therefore, you go to the tropics, go to Florida, it's damp. Warm air holds more moisture. So just basically very simple, gas physics, you can hold more water vapor in the air. So it's wetter, so it picks up more moisture out of the ocean and dumps it where it's evaporating and dumps it where it's raining, just cranking more water through. Yes, there's refinements and caveats to that, but that is the basic picture. So where it's been raining, it rains more. Where it's been dry, it dries more. And there's a map from the IPCC, and you see the deserty regions got browner, and some of the wetter regions got bluer. This is actually measurements. It's only got the land, and measuring rain over the ocean is almost impossible, so we measure the salinity. And that's the next one, if I can get it to come up. Why? Why me? What? Sorry. I'm pushing the wrong thing. Okay. This is the ocean surface salinity. Salinity, salt. You go out there and tell you the water is salty. Yeah, don't get a mouthful of that. Well, it actually varies. And there are places, in the orange places, it's saltier. In the blue places, it's fresher. So you get a little pedagogy here. The Atlantic is kind of salty, and the Pacific is kind of fresh, but they all have kind of salty areas in the subtropics where it's really kind of nice and dry, and like us, deserts and so forth, where we have big subtropical high systems. And so the air comes down from up above, and it's dry, and it evaporates water. And then it rains out someplace else. The atmosphere is really good at moving that water around. So that's what the ocean looks like. This is a map of evaporation minus precipitation. Where it's red is where it's mostly where it's net evaporation. Blue is where it's net rain. So you can look at these for a while and find your favorite climate patterns. But the salinity basically is related to the evaporation precipitation. So what we showed in the IPCC, this is from Drought and Wafels paper. That second plot down is that evaporation precipitation map. The bottom one is the salinity. The third one down is how the salinity has changed. And if you squint at that, and given that the data is kind of, not the best, it actually matches the ocean salinity pattern quite well. And so we've shown that pattern of wet, wetter, dry, drier holds over the globe. And if you look at the very top one, it's the water vapor changes, if I can get this to go. The trend in the water vapor, a lot of blue. Mostly it's getting wetter because mostly it's warmer. And there's some interesting structure to that too, if you're a scientist looking at that. Here's a projection 90 years from now. Dry area is drier, wet area is wetter. There's the map at the top. We're kind of in the orange area. Not good. Okay, onward. So finally, this is just back to summarize everything. This is what we're seeing, documenting. I don't have a lot of, I don't have videos or anything, but I'm just showing you the documentation of these very thick books of information. And this is the same one. The ocean warming dominates the increase in energy. The energy is absorbed about 30% of the emitted CO2. Acidification is happening, and the heat has penetrated all the way to the bottom. And finally, to summarize it all, maybe. Where is this supposed to point? The next speaker won't have this trouble. It's just me. So the Earth is warming. 93% of the heat is in the ocean. Hydrological balance, that means the water, is shifting now. We have evidence that it has changed. What we're seeing is actually climate change. The oceans are acidifying. Ice sheets are breaking up. Didn't talk about that much. Sea level rise is happening now. I did skip a little section on sea level rise. You can go on a website in NOAA and look at your Long Beach tide gauge, and you'll see over the past century, since 1926, you've gone up 22 centimeters here. That's the trend here. It's measured. That's what we see at Scripps Pier all along the West Coast. So we're already at 1 degree C. 1.5 is on the way, but it could be slowed down. 2 will happen if there's no action taken. And the consequences of that are way worse than 1.5. So let's do something. Thanks. I'm not touching it. How do we get to the next?
Good afternoon, everybody. I'm Bill Patzert. I'm retired, all right? But I'm not silent. Now, it's always a pleasure to be here at Jerry's Aquarium. I call it Jerry's Aquarium. And I want to congratulate the people here at the aquarium. You see the new extension that they're building? It looks fantastic. I just can't wait for it to open. Really looks great. And I want to thank the League of Women Voters for inviting me here. Now, I want to congratulate the League of Women Voters. We're talking about voting here. And actually, 100 years ago, the state of California ratified the 19th Amendment to the U.S. Constitution. Anybody know what that was? Right. Let my mom vote. All right? And so it's a great day. And I believe a year later that the League of Women's Voters was actually organized. It goes back to 1920. So congratulations. Now, last year I talked to all of you about one of my favorite philosophers, of course, is Yogi Berra. And Yogi always used to say, the future ain't what it used to be. But I'm going to change that a little because that's what I did last year. All right? So I'm not going to talk about the future. I'm going to talk about the present. All right? So we heard from our first two speakers about, what the future might look like. But let's look at the present, because it's not the future, it's right now, climate change. And it's us. Now, we heard that we're warming, we're melting, sea level's rising. Doesn't look good, yikes, right? Now, how do we know all this? All right? We know it beyond a doubt because we measured it. All right? This is not fake news. These are scientific facts. All right? And so what we have to keep in mind here, the basic premise, we're talking about voting this afternoon, is that long-range planning should always be based in public policy on scientific facts, not like fake news, which has become very popular these days, all right? So 3 things I'd like to talk about here are heat waves, droughts, and fires. A little different than sea level rise, all right? And the history of the American West has always been written in these great events. We've always had droughts, we've always had fires, we've always had heat waves. Now, are we getting hotter? Are we getting drier? Are there more fires? Are these extreme events, are they more frequent and more damaging? And why? And I'll try to touch on each of these things. All right. Now, California is heating up. Everybody recognizes that? No, we're beyond talking about it. All right. We're living it. So this is a history of the temperature, annual temperature. There's one bar for every year going back to the 1870s. And you can see that there's a trend in the temperature in downtown LA. So how much has the temperature in downtown LA changed in the last 140 years? Anybody want to tell me there? It's the red line. It's about 5 degrees Fahrenheit. So on average here in Southern California, we're anywhere from 2 to 10 degrees Fahrenheit warmer than we were in the 19th century. Now that's a lot, because the previous speakers were talking about 1.5, 2, 3 degrees. But the number here in Southern California is 5. That's a lot, all right? And we get days, the hottest day we ever measured in downtown LA was September 27th, and that was 113 degrees Fahrenheit. That was a warm day. Oh, there we go, I see. So, LA is heating up. Heat waves, I've done a lot of research on this, are getting longer and they're getting more frequent. There's no doubt about it. Now, the interesting thing is I said that the average annual temperature was 5 degrees Fahrenheit. So that doesn't tell you anything about what it was in February or perhaps what it was in August. So when you break it down by months, the average February is about 3 degrees Fahrenheit warmer. And that makes sense because the days are shorter. But when we get into August and September, the average temperature is 10 to 12 degrees Fahrenheit warmer than it used to be. Now, that's not global warming, but that's LA warming, all right? That's a lot, all right? And so when the global people tell you it's going to be 4 degrees, 5 degrees, 6 degrees warmer, we're way past that here in the greater Los Angeles area, the great megalopolis from San Diego to Santa Barbara, all right? All right, so part of this is global, about 2 degrees, as previous speakers talked about. But 3 degrees Fahrenheit is something we call urban heating. There are 20 million of us in Southern California. We've created a great megalopolis here, freeways, housing development, shopping centers, parking lots, all right? And all these structures, all this infrastructure creates its own heat, all right? And so the biggest increase in the heat in Southern California, part of it is global warming. But by far the largest piece is us, all right? So it's not just global warming. It's the crush of 20 million people in Southern California, 40 million people in, 20 million in Southern and 40 million in California. Now, one of the interesting things about this urban heat island effect is that as we absorb heat during the day, we tend to retain it at night. All right, this is a little complicated here, right? But the average low temperature, when's the lowest temperature of the day? 6 a.m., right. There's a man that pays attention, all right? All right? Just before you get up. That's why you don't want to get out from underneath those covers at 6 a.m., all right? And then the average highest temperature is what time? It's about 3 o'clock in the afternoon, okay? Now, the average lows are in the blues there, the blue bars, and these are by decades, going back for an entire century. This is an average over the decade. And you can see the interesting thing about the blues, they used to be lower, and now they're higher. And so when you look at the trend in the blues, which is the nighttime temperatures, compared to the reds, which are the daytime temperatures, it's the nighttime temperatures that are increasing. So the nights are warmer, All right? It doesn't cool off at night as much as it used to. And that's a signature of what we call the urban heat island effect. All right? And then, you know, what we see here is that, you know, you think of heat waves during the day, but there's heat waves at night. And so the average nighttime heat waves are essentially increasing over the past half century. All right? So we're warming. And we're warming faster at night than we are during the day. And that has a lot of interesting meteorological implications. All right? You know, this thing didn't work last year either, Jerry, you know? All right? All right, now here's some numbers I put together just for last summer. Remember the first column there is the daytime, the second is the nighttime, and the last column is the average, all right? And so this was for June, July, and August. Notice that this is the departure from normal. Notice, did it seem like it was awful hot last summer? It was hot. Look, the daytime temperatures were almost 3 degrees Fahrenheit above the long-term average. The night times were over 4, all right? And so it is hotter, all right? Part of it is global warming, part of it is you, all right? Now, let's project a little bit. Some scientists at UCLA have projected what it might look like in the next century, all right? And these are the number of days where the temperature is above 95 degrees Fahrenheit, looking ahead into the new century. This is in the 2050 time frame. All right, look at Bakersfield. I can't see the numbers from here, but somebody can read them to me, all right? It's hot, all right? But almost a quarter of the days, looking out into the 2050s, which is not that far away, the temperature is going to be over 95 degrees. All right, let's look at Palmdale. Same thing. We go from, right now, whatever that, it's about 6 or 8 days, and it increases up to into the 20s. You know, this is really a lousy clicker. Yeah. All right, and this is Santa Clarita. So it's interesting, you know, you can see that the farther you get from the ocean, the worse it is, all right? And of course, the good news, oh, I see what it is. You have to hold it up high, all right? All right, look at Long Beach. Now, Long Beach doesn't change that much. Why is that? The ocean, right. All right? The thing that really saves us here in Southern California is the great natural air conditioner, which is the cool Pacific. So the closer you are to the ocean, or the stronger the sea breeze is. So what's going to change us, would really save us from global warming and the urban heat island effect, is the ocean. It's the Pacific. So you see, even going out 20 or 50 years. So Long Beach is not a bad place to live, actually. Yeah. Now, this was an interesting one I got out of the New York Times. I live in Sierra Madre, that's in the foothills. And we really feel the heat waves up there. And if you were born, for instance, in 1960, you know, most of us here wish we were, but, you know, looking out, most of us were not, right? You can see what the average temperature looks like going off into the 21st century here. And, you know, and this is all based, actually, this curve. Actually, you can go, it was in the August 31st issue of the New York Times. You can go and plug in your own hometown or any place on the globe and create your own curve. It's a great little visual graphic, all right? And this is, by the way, this is based on the assumption that all the nations in the world will actually follow the recommendations of the IPCC, all right? And it turns out that nobody is, all right, because there is no enforcement policy. And so you can see what your future is. It's a warmer future, guaranteed, all right? So the important thing I wanted to make here, a lot of people talk about adaptation and mitigation. Adaptation is it's changing, get used to it, all right? Mitigation is try to cut our carbon footprint and cut down on the CO2 in the atmosphere, or maybe even scrub it out of the atmosphere, all right? But right now, we already are adapting, all right? So, you know, an interesting thing happened in the 1950s, all right? Probably the greatest invention of the 20th century when it came to global warming. What was that? Air conditioning, all right. And so my adaptation hero is Willis Carrier. You know, Willis invented the air conditioner in about 1906, but it didn't really go into widespread use until the 1950s. It became, you know, manufacturing became economic. And so now we all take it for granted, all right? Now, imagine Southern California, especially if you live in the foothills or anywhere around downtown, without air conditioning. Just imagine it, all right? The Inland Empire without air conditioning, all right? So we are adapting to global warming as well as what we've done to the environment and ourselves, building this great megalopolis, all right? And you know, of all the natural disasters, hurricanes, all right, sea level rise, tornadoes, what's the most deadly of all? Is heat. Heat waves are the most deadly, all right? Remember the great heat wave of 2003 in Europe? 70,000 people died in a week, all right? So love your air conditioner, all right? All right? Heat waves are the most deadly. And without air conditioning, essentially, a great deal of Southern California would be unlivable, not in 2050, not in 2100, but today. Now let's talk a little bit about droughts. Now, you know, the thing about droughts, they've been here for a long time. We have a long history of droughts. You know, the American Southwest is semi-arid. Long droughts. Droughts last a year. Droughts last decades. Droughts last 100 years, all right? All right? And one example of drought is, for instance, this is where I live, up in the San Gabriels. This is, we get a lot of our water from groundwater. This is called, right here in the groundwater basin for the foothills in the San Gabriel Valley Water District, all right? And notice what's happened here, say, you know, in the last 20 years. This is the level in the groundwater basin. So that's one measure of drought. I found about 200 definitions of drought, all right? All right, so this is at a record low level. And usually the people in the foothills get about 50% of their water from these groundwater basins. So for the first time, for instance, in Sierra Madre, in our history, we actually had to buy water from the MWD, all right? It was a shocker, you know, it was a shocker, all right? So there's one measure of drought. And this is very typical, actually, of the groundwater basins all over California. So we're in a groundwater crisis in terms of drought. And this, of course, this is my measure of drought in the American West. This is the lake level in Lake Mead. And you can see that since really about 1998, that the level in Lake Mead, all right, has gone down for about 20 years. Now, part of this is natural variability, and of course, I predicted all this 20 years ago. I did, actually. Maybe I got lucky, all right? But this is a crisis, There are 7 states and 5 Indian nations that take their water out of the Colorado, all right? And right now, we're almost at a level where it's a crisis, all right? More water has been promised than can be delivered, all right? So we're in heated negotiations with the other 6 states, all right? This is a crisis, all right? So that's one measure of drought. There we go. All right. Now, I also think of drought in terms of precipitation. Now, these are 2 interesting charts. This is the temperature precipitation connection here in Southern California. Notice since 2010, the temperatures have been going up. It's been getting warmer. And at the same time, the fall precipitation, September, October, November, December, has been going down. And we've seen this all over California. As the temperature goes up, the precipitation goes down. We're having drier falls. We're having warmer falls. All right. We see it in the snowpack. It makes sense if you have a drier fall. So this is going back to 1981, the western snowpack, all right? You can see that the trend, again, is lower. So it's melting earlier. The snow is coming later. More of it is rainfall. And so the greatest reservoir of water in California, which is in the Sierra Nevadas, is shrinking. And so that's what I call a snow drought. All right. So it's not only a heat and a precipitation drought, it's a snow drought. And this changes the whole thing because our entire water structure here, the great reservoirs, how we allocate water from Northern California to Southern California, depends on the snowpack as well as the temperature. So it's changing. It's different than it was, all right? That's why most of you don't have lawns anymore. Okay. All right. Then this is the other half of the equation, of course. This is the Sacramento River runoff in the spring. So normally the snow builds up in the winter, and then it melts slowly in the spring. It's captured in the reservoirs. They send it down to Southern California through the great aqueduct next to Highway 5. All right. But you can see, so it's drier in the fall, and so you see less runoff in the spring. And remember, there's 40 million people in Southern California, and it's mostly semi-arid. All right, now let's switch a little bit here about my favorite topic lately, and that's the record 2008 fire season. Yeah, it was by far the most deadly and destructive in our history. You know, it was a terrible thing, all right? Almost 2 million acres burned. So many houses. It was so tragic, all right? More than 100 people killed. Billions of dollars worth of damage, all right? So the question is, who was responsible for all this? And who's going to pay for it? How many people think this was global warming? All right. You think it was all global warming? How many people think it was all global warming? Oh, okay, good. All right, yeah. Such a smart audience. Yeah? All right. Well, you know, wildfires are getting more ferocious, all right? Is that you can see that the total area burned since the 1950s has been steadily going up. And so these fires are more ferocious. There aren't necessarily more fires, but they're bigger and they're more destructive. But there are fewer fires. That's interesting, huh? There are fewer fires, yet they're more destructive and more deadly. Now here's my favorite satellite image for 2018. And this was Paradise, the famous Paradise fire, all right? It was November, all right? You know, the interesting thing about this, Paradise itself, I think, is right about here, all right? The fire started at 6 a.m. in the morning, and by 2 p.m. on the same day, it was over. Can you imagine that? So that was only 8 hours that whole area got incinerated. So how did it go up so fast and furious? You know, how could that possibly happen? Well, for one thing, it was built in a very dangerous area, all right? It was built in the canyon that, with the Feather River flows from Lake Oroville, all right? An area well known for strong winds, what we would call Santa Ana's here in Southern California. And it was built not near the wildlands, it was built in the wildlands, all right? The zoning was almost criminal, all right? And, all right? By the way, this turns out to be the costliest global disaster, according to the insurance people, in the entire planet in 2018. All right. But, okay, here we look at it. Here's paradise. All right. You can see here's the Feather River. It starts. All right. Now notice, almost immediately, all right, there are only one way to get out, and really only two ways from the north and two from the south. And remember, the fire started so rapidly. It was over in 8 hours. In the first 3 hours, most of the evacuation routes were covered with fire. So that was criminal, all right? So it was built with no evacuation routes in a wild land, all right? Got it? In an area, by the way, 10 years ago, they had a big fire there already, all right? So, pardon?
That's how the land was cleared for development.
Right. All right, so there are natural forces here. We do have wildfire corridors that are usually associated with wind corridors. Here in Southern California, it's the Banning Pass, the Cajon Pass, the Santa Susana Pass. All right, and all the fires we had in Southern California have always been associated, especially this year. All right, that's why they always have them in Camarillo, in the Inland Empire, all right, rural San Diego County. Over and over again, they're always in the same places. Historically, we didn't build in these corridors, these wind corridors and these wildfire corridors. But as the population grew, all right, all right. Okay, I know. Let me finish, and then you can take your shots, okay? All right, so we've always lived in dangerous conditions. These fires have been around for centuries. The droughts have been around for a century. Santa Ana's, all right? But what happened is that the population just exploded here. And of course, in the search for affordable housing, in areas that we typically did not build in, we now build in regularly, all right? And so a lot of this, like you all told me earlier, is not necessarily global warming. A lot of this is just human behavior, all right? Dangerous zoning and sort of ignoring construction standards, all right, that would make an awful lot of sense in these areas. Okay, so not everything here, all right, is global warming in California, some of the problems that we have. So if I was to break it down, all right, what caused all these destructive fires, not only this last year, but in the last 20 or 30 years, all right? Natural forces is about 30%. That's wind corridors, Santa Ana's, all right? Climate change, maybe 20%. It is drier. The ecosystems are changing in the wildlands in California. But only 50% of what we've seen is human behavior. And now I'm not blaming individual homeowners, all right? I'm blaming large-scale zoning and construction codes. All right. Now here's an interesting one. All right, this is Malibu, which is like the foster child for dangerous living. All right. So I'm going back to the beginning of the century. right here, up to the Woolsey fire. Anytime a reporter calls me and says fire, I usually say Malibu. All right? Malibu is mostly in the wildlands, all right? It's mostly unzoned. All right? And they've been going on forever, these fires. And not everybody there is wealthy, like you read in the LA Times. There are a lot of people that live out in these wildland areas, and they have the same problem that they had in Paradise. Very few evacuation routes in many cases, all right? But it's heartbreaking, and it's expensive, all right? So again, let me say it again. The Woolsey fire, the Malibu fires, part of it is just natural. When those winds come down through the Santa Susana Pass, Santa Clarita River Valley, and then they make their way into all those canyons in Malibu, and the TV crews, whenever they want wind, they always go to Thousand Oaks and Santa Clarita, all right? It's been happening forever. Part of it is climate change. The wildlands have changed, all right? But most of it's human behavior, all right? So, for instance, here's a map I stole from the LA Times. This is the Los Padres National Forest, all right? And from 1950 to the present, these are all the areas that are burned. That's a lot of fires. It's a lot of areas. You know, that's over and over again. That's deja vu all over again. Now, one thing that is interesting that's happened, there was, this is an article from this morning's LA Times, Bettina Boxall, is that the ecology, because we're having so many fires, frequent fires, that the ecology of the wildlands has changed. A lot of the scrub, chaparral, sage is disappearing and is being replaced by what? Grass. Now, where did grass come from? Ornamental grasses from new housing developments, okay? And grasses burn fast and they burn furious, all right? And so a lot of the, for instance, the rapid fire we saw in Paradise and in Malibu, by the way, that only happened in 2 days. The Malibu Woolsey fires is because of the grasses. And so the ecosystems have changed in the wildlands, all right? And they're feeding these fires, all right? So the fires are fiercer and they are more frequent because these grasses. I didn't mention national forests once here, all right? I'm just talking wildlands. All right, so here's a little animation, if it's going to work here, of the Woolsey fire. Now, so, okay, this is one day. That's day 2. There's day 3. So you see how fast it happened? Yeah, a lot like the Paradise fire. It happens fast. Yeah. All right. So there's a lot of words here, all right? So fires, floods, mudslides, they definitely are worse, all right? And because the population in Southern California has quadrupled since the 1950s. Went from 10 million in California to 40 million. From 5 million in Southern California to 20 million. San Diego County went from 600,000 to 3.6 million in 50 years. That's not quadrupling, that's a factor of 6, all right? All right, and because of the need for housing, we've been careless in our housing development and certainly in our construction codes, all right? Seen a lot of invasive species in the wildlands like grasses, all right? And so a lot of the mudslides, all right? Everybody knows they're coming, right? Now, for instance, what happened in Montecito is all those multimillionaires in Montecito, they didn't clean out the catchment basins, all right? So a lot of people died, all right? the catchment basins were full. And we've spent billions of dollars building catchment basins all over the San Gabriels, all over billions, all right? The LA River, for instance, is one example, all right? All right. So the simple thing here is that not only do we bring global warming, but we bring fire, floods, and mudslides, all right, that definitely cause mayhem. And the important thing here is that the simplest formula for fire is people bring fire. 95% of these things are ignited either accidentally or intentionally by humans. All right. And that's a bigger thing than global warming right now. All right. Okay, now this gets to me my punchline. So what we really need here is legislation. Like everything in America, what counts is who you vote for. Because you can't change things with good intentions, all right? All right? Just by driving a Prius doesn't slow down global warming. Got it? Or taking out your lawn doesn't alleviate the drought. You have to legislate it. You have to make laws and you have to enforce it. Otherwise, it doesn't happen, all right? And so the way to improve the situation here with the fires and with many other things is we need better forestry and wildland management, all right? And that mostly comes, by the way, at the state and federal level, all right? Okay, and this is just a quote, the guy that was the head of CAL FIRE, a really competent individual, Ken Pimlott. He just retired. But anyhow, he points out, look at the red one. But firefighters are living climate change, staring in the face every day. And so the firefighters know it's climate change, but they also know it's the other things that I just mentioned here previously. All right, a lot of it is us. And these things have to be legislated. All right. And of course, my culprit, I wouldn't feel good if I didn't have to beat you up with this one, all right? All right, in the end, there's no world problem, anything that doesn't get worse with increasing population, all right? So in the end, it's all about population. 7.4, 7.6 billion is too many. 10 billion people, all right, is mayhem. And as Jerry mentioned, one of the things we have to really consider seriously here is they have to improve economic and educational opportunities for women. That's what it's all about. But you can't separate the population from warming, melting, rising seas, energy crisis, water crisis, the food crisis. The water and the food crisis, by the way, gets us before the global warming does, all right? And not to mention political crises, all right? So, you remember I took the first top photo with my Brownie in 1902. And then I went back with my iPhone and took it again last week. Yeah. And so let's look back over that century. Is that, the world population went from about 2 billion to about 7.4, but the California population went from 1 million to 40 million, Huge growth here in Southern California, or California in general. So there's no doubt about it. This is the best place in the world to be poor and rich, all right? Now, so these are all existential threats. We're an existential threat to ourselves. Global warming is an existential threat to the planet and to Long Beach and the aquarium. Right? But in the short term here, probably the biggest existential threat to civilization, all right, is the Trump dumpster, all right? All right. What we've been talking about is adaptation and mitigation. Now, everything that this administration stands for is counter to all that because they don't believe it's happening, all right? They don't believe global warming is real, all right? All the environmental laws that I fought for in my youth, the Clean Air Act, the Clean Water Act, they're all being repealed, all right? All right. So here's just a few, all right? The Environmental Protection Agency, he says he's going to withdraw from the Paris Climate Accords, which is the only hope internationally to bring everybody together, all right? It's unbelievable, actually, all right? It's going to reverse all the standards on automobiles and trucks, all right? Anyhow, so what's my point? All right? The only way to get through all this is that we need science-based public policy, all right? You've got to believe the scientists. The scientists actually have it right, all right? And so this pattern we've seen in the US Congress and in the White House of trashing science, all right? Not only is he trashing it, he's trashing it by legislation. Remember, it's America. The way you change things, all right, is you legislate it, all right? And they are legislating it, but they're legislating it the wrong way. All right? All right? Come on, man, you got to vote these bums out. I know you're nonpartisan, all right? All right? And so... But, you know, I never thought I would see this in my lifetime. I'm retired now, I can say this, you know. Okay. Okay, you know, Yogi Berra is another one of my favorite philosophers. So was George Carlin, you know. Yeah. Yeah, as George said, anyone in the U.S. can be president. And he said, that's the problem, yeah. So, you know, I say vote the bums out. Get out the vote. And we did, you know, the midterms looked a lot better. Hopefully it was because of the League of Women Voters, yeah. All right. So global warming is our forever existential threat. We're never going to get out of it. The world is going to continue to warm. The question is how rapidly, all right? You don't go backwards. There's no reversing or stopping global warming. The question is how much, all right? So it's an existential threat forever. But there's a short-term existential threat, all right? And the only way we deal with that is not by driving a Prius, but is who we vote for, all right? Because adaptation and mitigation can only happen through legislation, not through good intentions or some guy standing up at the aquarium in the Pacific giving you an entertaining talk, yeah? Am I done here? All right. Okay, so the bottom line is if we want a livable planet, everybody has to vote smarter. And in countries where they can't vote, we have to help them vote, all right? We're lucky we get to vote here, all right? So I have a couple of challenges here, all right? For instance, this is an interesting one. This was the 216. More than 10 million environmentalists, all of them did not vote in the presidential election, you know? So you people are not doing your job, you know? You got to get more people out there to vote. Right. And then here's my favorite, you know, is that why don't young people vote? Where are they? Are there any young people? Yeah? Where are they? Oh, there she is. There's the one young person. All right? All right? Get them to stop streaming and vote. Yeah? So there's a challenge for you, yeah? So looking ahead here to 2020, 2018 was good. What we really have to do is recruit more young folks, minorities, and immigrants, because that's where they don't vote, all right? And so, you know, all you nice elderly white people out there, that's nice. You know, they all came here today. All right. But you're not the problem. All right. No. Okay, on that cheerful note, you know, I'm done.
So I'd like to start out just by congratulating all of you for being here right now, because there's a lot of things you could do on a Sunday afternoon, and you've chosen to really look this mess in the face, and it's really quite brave. And so sometimes when people see how slow progress on climate change has been, they ask, isn't there some new technology we can use to fix this impending disaster? The short answer is it's complicated. There's no single great technology that will solve this whole mess altogether. But there's a few things that could be used to help with part of it if designed the right way. So I'm going to give an overview of some of them for 20 minutes here. So this slide didn't show up, but that's okay. The thing about the situation that we're at right now is that to keep warming at safe levels, the consensus of science is that we need to remove carbon from the atmosphere. So this is from the IPCC's special report on 1.5 degrees that was just mentioned. And I'm going to try to translate this to English here. Basically, it says that all the pathways that they've looked at that are limiting warming to that 1.5 degrees with limited or no overshoot, that means without way overshooting the targets and then bringing it back down, require carbon dioxide removal between 100 and 1,000 gigatons over this next century. So a gigaton is 1 billion tons. For context, the current level of emissions is about 40 per year, 50 if you include other greenhouse gas equivalents like methane and so forth. And so what they're saying here is this carbon dioxide removal would be used to compensate for residual emissions. So when they say that, they're imagining that there's going to be some residual emissions going on because some sectors are really hard to mitigate, like aviation, like steel production, some heavy industry. So the idea is that those would have some small portion of emissions and it would be compensated by removing carbon from the atmosphere. Another thing I want to highlight about this statement is, so return it to global warming to 1.5 following a peak. So what's baked into these model simulations is really a temperature peak and then a decline. And so let's go into what this means. This is an illustrative look at our carbon budget. We don't know exactly how big this carbon budget is, so this is illustrative. But you know, each of these squares represents one of those gigatons. And so that's what we would have left before we breach that 2 degrees. As I mentioned, 40 to 50 gigatons per year currently being emitted every year. So the next year it goes up. In a decade, you know, you've burned through more than a third of it. And then by 2042, that's all the emissions that are left before we reach 2 degrees, right? So the thing is, we don't really know how much this budget is. It changes based on new information. And so maybe, you know, we don't have as much as we thought we could before we reach that limit. And we get there much earlier. So this is why people talk about overshooting temperature targets. And this is kind of the one graph that I hope people will take away from this 2 degree picture, right? This scenario would involve a very near-term peak and pretty dramatic ramp down. Another thing is, so this bottom part would be the negative CO2 emissions. And those actually start to be generated quite soon, around 2030. And then near the end of the century, around 2080 or so, the world would actually be sucking out more than it's emitting. That's the net negative part, the very dark green at the end of this graph. So that's the aspirational curve. How is that actually accomplished? I'm curious if you might have heard of some of these terms. These are an emerging vocabulary to talk about this goal of removing carbon. So negative emissions is something that you might hear in these global scale policy documents. There's also an emerging talk about carbon tech, a new carbon economy, carbon utilization. And then drawdown you might be familiar with from the best-selling book by that name about drawing down carbon from the atmosphere. And regeneration is a kind of related concept when you get into some agricultural techniques. So I'd like to talk about some of these. The idea with drawdown is they actually critique this talk about negative emissions. They prefer to talk about sequestration, which they call carbon positive. And that's basically a catalog of a bunch of different ways to draw down carbon. These images here are focused on regenerative agriculture. They're from a local organization called Kiss the Ground that does speaker trainings about how to talk about soil carbon with your friends and neighbors. So really focused on soil carbon sequestration. So there's three basic techniques for storing more carbon in soils: planting perennials, using cover crops, and not tilling the soil. And this is something that's gaining a lot of momentum and enthusiasm. There's an emerging regenerative agriculture, regenerative organic certification backed by a few companies like Patagonia and Dr. Bronner's and the Rodale Institute. You can now purchase, a beer grown with regenerative grains that have super long roots, which stores more carbon in the soil. There's now, from the North Face, a collection of wool products that are made with sheep that are grazing regeneratively. So there's kind of this very kind of niche but growing awareness about soil carbon sequestration on the consumer front. And then you have carbon tech, or carbon capture and use, that's thinking about how to productively use captured carbon. And industry advocates claim that there would be $1 trillion market for products made from CO2. I think that's a bit ambitious, but and the other thing to keep in mind when you hear these kind of claims is that because of the scale of our emissions, we can only probably productively use less than 1% of what's currently being emitted. It's not possible to transform it all into new sources of value, like shoes out of carbon. But there are things like cement production, for example. So cement accounts for about 7% of global carbon emissions, actually. And there are ways to produce cement that it actually can suck up CO2. So that's one interesting front. A lot of people ask, can we just remove carbon naturally? We know that plants and trees suck up carbon. And in the US, forests already offset about 13% of the country's carbon emissions. Globally, that's even higher, maybe 30%. So there's definitely a lot more we could do there, but you do run up against land constraints. So there's differing estimations of how many new forests you could plant. For example, drawing down 1 gigaton of CO2 would require planting new forests over 70 to 90 million hectares, so twice the area of California. That's a lot. And eventually you start running up against these competition for food production. But people say that, we could just stop using our land for grazing cows, switch to a more plant-based diet or cultivated lab-grown meat, and then you could devote more space to these forests. So there's all those discussions, as well as a lot of potential for storing carbon in soils as well. One thing about this that is sometimes missed by advocates who are really passionate about these is that they can't continue removing carbon indefinitely because these are sinks that become saturated. So over time, the rates of what you can do year on year is going to plateau. Those soils are going to have as much carbon as they can hold. Those forests are going to be planted and mature. So on the order of decades with soil sinks, or maybe a century with afforestation, that's going to be as much as you can store. And the other thing is that they're vulnerable to changes like wildfires. You could lose carbon you'd been making on storing there. Or if you've changed your farming habits, you have to keep doing those practices, otherwise you might lose the carbon again. So just to illustrate that, if you really spent a lot of energy and effort getting those systems changed, the agriculture, the land use changed to store more carbon, and you managed to do, 5 gigatons per year over half a century, well, that would just equal about 5 years of emissions at our current rates. So if you kick the can on bending that curve down for 5 years, that's using up a lot of work you've put in for that natural carbon storage. So that's why I'm going to talk a little bit about some geological or engineered approaches as well, which I think are pretty vital for this. And the National Academy has just put out a research agenda report, which is very long, but worth taking a look at least the press coverage of it, because they really delved into these 6 different methods of removing carbon. Coastal blue carbon, so storing more carbon in coastal ecosystems and mangroves and seagrasses. Accelerated chemical weathering of rocks, which I'm not going to talk about today due to time constraints. Afforestation, soil carbon. And I'm going to talk a little bit more about the 2 in the middle, direct air CO2 capture and bioenergy with carbon capture and storage, because these would be systems that could continually remove carbon year on year if they were scaled up. And so with direct air capture, the way this works is that you build machines that extract CO2 from the air chemically with some kind of sorbent that would stick to it, like a sponge, for example. And then you would pipe that carbon to be stored underground if you wanted to remove it permanently. So the image here on the top is a plant in Switzerland that does this. It does this at a cost of about $600 per ton right now. And it's selling that carbon that it captures to greenhouses for growing more things. So it's quite expensive right now. These are kind of the pilot scale demonstration facilities. The bottom picture is a visualization produced by some folks at ASU about what it might look like if it was scaled up larger. And so this is something that we know how to do. The challenge is making it more economical, and the challenge is also dealing with the energy needs of it at present. And right now, nobody's really going to pay very much for this waste disposal, because right now it's considered fine, basically, to put all that waste into the atmosphere for free. So one of the first imagined markets for this technology is something called air-to-fuels. There's a company called Carbon Engineering up in British Columbia, which is working with this. And actually, Chevron and Occidental Petroleum just announced this week that they're investing in that technology. And what they can do is take the captured carbon and turn it into a fuel by combining it with hydrogen split from water. And then that synthetic fuel could be refined into gasoline. So that is not getting you to carbon removal, obviously. It's a mitigation method for lower carbon fuels. And the other important market for this technology is enhanced oil recovery, which I want everybody to be aware of. So right now, these oil companies are interested in purchasing carbon because right now, they're mining it from natural reservoirs in Colorado or New Mexico and piping carbon dioxide to depleted oil fields to inject it underground and get more carbon out. get more oil out. So that's one market. This is one of the reasons why this technology is a little bit controversial, but also a reason why there's bipartisan interest in it, which I'm going to talk about in a little bit. Another thing that's been imagined, that's used in these modeling studies a lot, is bioenergy with carbon capture and storage. So the idea is that you grow a bunch of biomass feedstock, you combust it in a power plant where you can separate out the CO2 and store it underground. And I think the modelers put that in models because this is all technology that exists. However, if you scaled it up to this level, it would have huge land demands. So no silver bullet there either, but some potential, and some ethanol facilities are looking at installing CCS in their plants for this purpose. And so underpinning both of those is the capacity to store carbon safely underground. And so the figure here on the right is Dan Sanchez at Berkeley and colleagues modeled what kind of a pipeline network might be required to reach some of these targets. So roughly you'd need 1,000 facilities to draw down a gigaton of CO2. So if you do the math, if you're trying to scale it up, you're going to need 10,000 plants. So you really have to picture an infrastructure on the scale of the fossil fuel industry that we already have, only for putting it back underground. So a huge industrial infrastructure. On the other hand, we have built this out for oil. So should we build it out for cleaning it up? That's the question I'd like to pose. And there's a lot of environmental justice considerations, all kinds of considerations about this. But the carbon is hurting people when it's out in the atmosphere, so perhaps it would be safer to put it underground. And one of the things that the Academy recommended research on in its report is further study of induced seismicity, because of, as you've probably heard about from fracking, there's been issues with earthquakes in places that didn't used to have them. So they're really thinking about studying the geology even more. I will move on to something even more dramatic, if you can imagine that. All of this would take a lot of time to be scaled up. So if you imagine business as usual, emissions cuts, carbon removal. Some scientists have also suggested a solar geoengineering intervention to so-called shave the peak off those temperature overshoots to minimize some of the damages that happen in that space. And so that's what I'd like to talk a little bit more about. And the basic question on their minds is, if reflecting sunlight by putting particles in the stratosphere would lower global mean temperature, could we do it on purpose? Here's the basic idea, is that clouds and other light-colored surfaces like ice and particles that are already in the atmosphere can all reflect light back into space, forming a kind of cooling shield. So how could more light be reflected? There's a number of ideas. One is to increase the amount of clouds and how reflective they are. That would have been worth talking a little bit more about. I'm not going to, but some researchers are studying whether you could create clouds in marine environments around coral reefs to cool them off a little bit and buy them some time. I mean, all of these methods here that I'm talking about are really just kind of triage, like emergency medicine for the system. Not desirable, but like life support type of measures that are pretty drastic. And the other main idea that has received the most attention is putting reflective particles, aerosols, into the atmosphere. And so one important consideration is that, as was mentioned a little bit earlier, aerosol pollution is already masking global warming between 0.5 degree and 1 degree. So if we do clean up our air, which we're trying to do because of all the negative health effects, that would actually have more warming effects. So people got the idea of studying this by looking at volcanoes and observing the cooling that had happened, especially following Mount Pinatubo when there was good monitoring technology to track all this. Sulfate aerosols were put into the stratosphere by the volcano, which resulted in global cooling of about 0.5 degree. And so if you had such an intervention, the particles would be put into the stratosphere, which is a layer of the atmosphere above all clouds. They would stay there for a couple of years and then fall back to Earth. And important to note, they would circulate around the whole globe. So this isn't really something you could target too much to a certain location. And this has been scientists have kind of known that maybe you could do this. This is a paper from 1974 by some pretty famous climate scientists that looked at all of these different kinds of things you could do if you wanted to stabilize the climate. And, this paper, they were not suggesting any of these. They thought they would kind of be terrifying. But, as they were really on the front lines of realizing climate change and what was going to happen and kind of brainstorming. So this has some history behind it. And as far as how operationally you would place these particles in the stratosphere, chances are that somebody would design an aircraft that would do it. And in terms of what you would put in the stratosphere, this photo is taken over sulfur at the port down here. Sulfur is something that might have less risks because it's already present in some degree. Other discussions are around calcite, titanium, diamonds, etc. And so into the tropical stratosphere would cool the planet globally. Maybe there's some refinement that could be made to cool the Arctic, but I'm not sure that's very promising. And so why would somebody even suggest such a drastic thing as modifying the amount and type of sunlight coming down to Earth? It would be 1% to 2% of incoming sunlight. And the reason that scientists are modeling this, and I'm not trying to say that there's a lot of scientists, there's maybe about 100 scientists who study this, doing research with a budget of a couple million a year. So it's not a huge field of research, it's pretty niche. It's that they've looked at these kind of model scenarios and they have in mind a worst case climate change scenario that we may or may not be heading for. And they compare it, and then they say, well, this looks like it might be better than this worst case. There's a whole host of potential negative impacts with this, including damage to the ozone layer, interference with precipitation. It's not a cure for ocean acidification. It could widen the skies. And the ecosystem responses, I think, are among the most understudied because I think ecologists tend to look at this idea and they think this is too crazy to even study because they have a very complex systems perspective, And then what I want to highlight also is the termination shock. So if you begin a solar geoengineering intervention and suddenly stop it, the warming that you are being suppressed hits at once. And that's something that species, including our own, could not adapt to very well. So you might hear, rhetoric in the political sphere at some point that, solar geoengineering would be a choice, between solar geoengineering or mitigation or a substitute. And that is absolutely the wrong way to think about this. And the reason is that if you want to stop the solar geoengineering intervention, you have to remove the carbon from the atmosphere so that you can ramp it down again. And in order to remove all that carbon, you need a massive amount of renewable energy to be powering the processes that are removing the carbon. Otherwise, it's not carbon negative. So really, the only way that you could responsibly even suggest doing this is if you're also planning for massive amounts of carbon removal and renewables, and you have the policy there in order to imagine a future where you could end doing the solar geoengineering. And so I'm bringing all of this up in part because there was a hearing at the House of Representatives, House Science Committee in 2017, where there were some rhetoric about, isn't this a cheap and easy solution? And my own take on it, my personal take after thinking about it for a decade, is that it's definitely worth doing research on, because these worst case scenarios of climate change are so scary that we should know if something like this could buy us time or if it would be a terrible idea. I mean, I think we need the information. So just to wrap up with a couple slides on the state of the political discussion on these. As far as carbon removal, there's been a lot of momentum recently, I would venture to say. I'd encourage you to read this op-ed by the senator from Wyoming that came out a couple weeks ago in the New York Times. I personally was not a fan of his framing or argument, but it's very interesting to have, a Republican senator acknowledging climate change, saying that it's a problem, and interesting to take a look at his argument. He was a sponsor of the Future Act, which was a piece of bipartisan legislation passed last year, pretty remarkable, that reformed this tax credit for carbon capture and storage, and also co-sponsored the Use It Act, which I think has passed both houses but hasn't been signed, which also funds research and about direct air capture. There's also a lot of state-level policies. The state and regional level are really great levels to think about engaging with carbon removal. Some other countries have been orienting their policy towards these goals. And as far as solar geoengineering, there's really not a lot of discussion of it in the political sphere. But I wanted to talk about it today because I imagine that could change quite quickly, especially in a scenario where there's not enough progress on mitigation and climate action. And the national academies are starting a new study on it. There's a small field experiment this year that is looking at some of the stratospheric chemistry involved. And this is what the IPCC's special report on 1.5 degrees said. They didn't look at it really because some measures may be theoretically effective in reducing an overshoot of targets, but there's large uncertainties and knowledge gaps. And they mention the institutional and social constraints and impacts on sustainable development. So I don't know where all of this is going, but I wanted to make sure you're all informed about it, because then you can engage, civically with it. And I'll leave it there.
Okay, I know everybody's probably really anxious to stand up and stretch their legs, but I wanted to make an announcement. Because climate change is a generational problem, and it's going to be our children and grandchildren who suffer the direst consequences because of our failure to address this problem head-on in a timely fashion. But because we continue to hope and we have faith in the next generation's commitment to the environment, the League of Women Voters and the Aquarium of the Pacific are expanding their partnership. So we are very pleased and excited to announce the establishment of the Student Climate Change Award. So at next year's symposium, it is our intent to award $1,000 to a high school student or a team of students who have submitted a project related to the themes of climate change or awareness. Details are going to be published in the coming months. And I know from having handled the reservations list that we have a number of teachers in the audience today. So I hope if you're teaching high school in the Long Beach Unified, you will encourage your students to participate in this award. So thank you, and we'll now have an intermission. So that's going to be a 5-minute intermission.
next generation, right? Oh, excellent. Well, it's a growth industry.
Thanks. I'm sorry, I
Very
thought
deep.
you were going to call time.
No, I was never.
Where are you studying?
Okay,
In California have been working
Great. Congratulations.
and using predictions
Those,
of climate change
you know,
that aren't the
those
bare
are
Okay.
drought.
hello,
There's
can
always
you
drought.
begin taking your seats?
and for example, there's a project that's kind of an all
Oh, yeah. No, I live in Sierra Madre.
Hey, Doug.
You know, back where global warming is real. So I always say, if you want to know what global warming is like
Hi,
in
Doug. How
2060,
are you? Good.
don't use your air conditioner this summer. Where do you live? Oh, that's why. Yeah. 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 Elderly, children, and pets suffer in heat waves.
Actually, when there was a heat wave in Chicago,
So Scripps has,
People died.
before you were born, yeah, I worked in city government. We were all
we have a new
called up
faculty
and
member, Mark Merrifield, who's senior faculty.
Could we get everybody to have a seat? We promise we'll have you out of here by 6 o'clock. Please come back and take your seats.
Famous heat waves in Chicago where 1,000 people died. All right, good luck to you.
Right, they can engineer and pay their way out of the problem is what's interesting, yeah.
All right, good try, Holly.
All right, we're going to resume. We're going to have you out of here by 6 o'clock. This is a chance for those of you in the audience to ask anybody on the panel a question. And so if you want to bring some of these issues back to Long Beach and what it may mean to those of you who live on the peninsula or in Naples. And while people are getting settled, I want to make a plea with the League of Women Voters. It's very clear that trees are good. They improve air quality. They offset some of the urban island effect, and they're beautiful. I think you, as the League of Women Voters, should ask the city of Long Beach, why are they preoccupied with cutting down so many of our large, mature trees? And don't take a simple answer. Press on the cost. Those trees take 100 years to grow. They beautify our streets. They cool the climate. They clean the air. I think it's a tragedy. That's a personal opinion. Right. All right. Who has the first question? And you can ask anybody. Yes, who would you like to direct your question to? I'd like to direct it to all to the entire panel. Okay, go ahead.
And the League of Women Voters. This is wonderful. It's great everybody's here. Why we haven't heard any mention of what's happening here in California, which is the community choice energy movement. Oh. And so I would like someone to speak about community choice aggregations and the growing number of these across the state and what we think, because I'm in on it, but I'm for it, but let's hear what...
Now, you want to go ahead with that?
I'll just say my personal example that I started off my talk with was our solar power and our Bolt. I'd say that our buying a Bolt was due to there being government incentives. Our solar power is because of community aggregation in Solana Beach, and I don't know much about it, but this is just from a user up, it's attractive to me to participate in that because it's been made available, and there are incentives. And it is important to get away from, to get all the alternatives for the energy out there that we can get. And I know there's controversy about it. And others probably know more about how it actually works.
Well, I'm not sure that I know more about how it works than perhaps you do. You sound very well versed in it. But yeah, it's something I'm really excited about, particularly because I've found that some of the large scale installations out in the desert, for example, have occasionally negative effects in terms of breaking up carbon that's stored in the soils there, and questions about who the benefits and the power flows to. So that's why I'm really interested and excited about this community scale.
And we had a program here about that at the aquarium about that sometime last year. You want to give a 60-second summary of what the essence is of the program?
Oh, no, it's just, you can look this up, this is California has led the way on this. And there's just it's a huge thing that's happening. There's already 8 million people, I think, in the state who are receiving their energy through community choice aggregations. And so CCA would be the three things you'd Google Cca California Community Choice Energy or Community Choice Aggregations. But at any rate, this is not like controversial in any way, because this is kind of sweeping. There were only 2 of these, one in Marin County and Sonoma County 3 years ago, I think, as recent as that. And now I think there's 11 or 12 of these. Most of the Bay Area is now covered by these aggregations. Sometimes they're referred to as like user-owned utilities. The thing is that they're mandating, this is the way that we're mandating that we meet these obligations for enough solar. So there's just a wealth of information. There is now an association of CCAs. So they have a business association and everything. I mean, this is conventional, to be perfectly honest with you, but we've been slow in Southern California in recognizing or adopting. So.
All right, thank you. So people know what to Google. CCA, and way in the back, the white you.
Oh.
Yeah, hi, and I do appreciate also the League of Women Voters putting this on, and I want to encourage them to take it a step further, recognizing that yes, voting is important, but I think going beyond voting and advocating and being constantly engaged with the policymakers is more important than ever in terms of this issue. More than 20 years ago, I took classes in environmental policy, and I'm super frustrated as to how slow everything has been going. And my own efforts, I'm just at a loss as to how to get through to people, not just politicians, but also just the general public. The only people I can talk to about this are people who are in science or somehow just take it for granted that science has got to be correct. I'm not going to question it. So I would like to see maybe more education of the of advocates like ourselves on how to get through. And I think starting with the scientists, maybe changing their changing their language. But I think it's really hard for you guys to get through because people, the eyes glaze over. You get bombarded with all this data. You don't really understand it. And then there's people who think they do understand it or they understand a little bit of it and they start questioning it. And for people like me, I'm not in the field and I start hearing, well, but what about technology or what about the overall trend? And the first speaker mentioned how, it has happened before. So that's what I hear from people. It has happened before. We see graphs that show 5 years, and then people come back and go, well, that's just a little blip in time. How do I argue against that as a basically a lay person?
How can she make her case in a more compelling way? We have 3 experts to my left. What advice would you have in terms of how scientists can work with people in the public to advance the argument?
Well, that's just an excellent question because I will admit, as a scientist, sometimes scientists don't communicate in a way that other people from other fields or other walks of life can understand easily. All right. But on the plus side, science is being taught better and better in the public schools and the private schools across the country. Science education, all right. A revolution in the last couple of decades is there are more and more, for instance, young women being included in science education. When I did my degree, there were very few. Now I think there are more women enrolled in engineering and science courses than there are young men, all right? And so your kids get it in school, all right? The internet, there's a lot of material that's easily understood and spoken in plain English rather than scientific jargon that's available, right? The newspaper's science journalism is better than it's ever been, and so you just have to make the effort. But
Although there's a lot less of the science journalism. Bill, the New York Times closed down its environmental desk. I think there's only one environmental desk now at any major newspaper in the United States. So what's reported may be better, but there certainly is not as extensive. Lynn and Holly, what would you add to that?
I would say there's no one-size-fits-all answer. It really depends on the person you're speaking to and understanding where they're coming from and what their values and concerns are, and then linking to that. Because climate is such a multifaceted issue, there's going to be some way to make the link. You know, if the person's a farmer, talk about the impacts that they might have already noticed. You know, if the person's religious, maybe look at Catherine Hayhoe's work about working with evangelicals that she's communicated with, and maybe focus less on the science. For some people, focus on the risk. So even if there is uncertainty and you don't know for sure, or that person doesn't think they know for sure, well, if there's a risk of this terrible thing, wouldn't you want to take some action? If the person's in the camp where they think there's climate change, but they're just not sure what the causes are, then maybe focus on adaptation and discussions with them. That there's going to be a point somewhere.
Lynn?
Oh, I just say I'm stunningly bad at it. So I've never quite gotten it right to get out of the weeds. I'm married to a climate scientist as well who does the ice bubble stuff, and he can convey it really. There are a few people that can do it really well in the circle I'm in. The best talk I went to was Ray Pierre Humbert, who started with a picture of cyanobacteria showing that there had been a massive change. He talked about mass extinctions, and one talks about this being a mass extinction. It is. And so you can, just as Holly said, you can relate to different people in different ways, and that was a really impactful way to evangelicals, it's to, or religious, anyone, it's stewardship of the planet. What are you doing dumping all this? Why are we living in a sewer? That's actually the image I like. We live in a sewer. In the 19th century, we cleaned up our cities and people survived much better, much longer lives, much better health. This is the health crisis now.
I think all three of you are very good at describing the science to general audiences. I would also suggest, though, that Sea Grant, we have 2 Sea Grants in California. We're one of 2 states that has 2. They're in the business of translating scientific information to end users. And we have the urban Sea Grant program at USC, and then we have the California Sea Grant program at Scripps. And I would contact them. Who has our next question? Right here in the front row.
I have the mic, so I'm just going to speak. I have 2 questions to ask you, but I want to address...
You only get one. We've got.
Well, I want to address what was brought up earlier, because I'm technically a millennial, and I studied research, but I decided to go into medicine and was pre-med last minute because I didn't want to rely on government-funded grants to be an oceanographer. As we see now, part of why I think young people are not voting is because we've lost faith in the political system that is gerrymandered in a way that we need 9% more than 50% on average to get Democrats who believe in climate change and legislation. So this is why, even though I'm not a Republican, I haven't read that New York column about innovation over regulation. Personally, and I think a growing number of millennials who don't vote, unfortunately, believe more in innovation. And I think the problem is, as you mentioned, cross-disciplinary. Scientists do science, doctors do medicine, and the problem is having, I think, a need for environmental journalism. People actually bringing this to the audiences, like environmental YouTubers. Because yes, you're right, there's a growing epidemic of just crippling anxiety amongst millennials who have to deal with the mess that the baby boomers left us in. I mean, really, it makes me emotional just to talk about it. And, you know, we also have this educational debt that baby boomers didn't have. So we don't have as much options. And so my question is, what can we do day to day other than going vegan? And that's my question. Nobody, you did mention in passing, Professor Buck, the water utilization and carbon methane impact of agriculture. And there's a growing movement amongst millennials who are making these documentaries like Cowspiracy.
So what can we do with our diets that will help?
How impactful is veganism? Because all I know is what was in documentaries like Cowspiracy, Climate of Doubt, or Chasing Corals.
Some discipline
and
here,
also,
or people
is there
who wanna
anybody
ask
who's
questions
bioengineering chloroplasts or so my question is, considering photosynthesis.
We have your question, ma'am.
That's my question.
We have your question. What can people do, but through their diet, the choices they make, to lessen, not solve, but lessen some of these issues, whether it's climate change or drought, any of these? Anybody have some thoughts on this? I have some, but I'd like to hear yours.
I don't have any.
No, wait, we're going to keep it up here first.
Okay, I think you've articulated a lot of your frustrations, the frustrations of your friends, millennial generation, and at the end you got around to veganism, all right? Well, let me just say that I'm with you on veganism. It turns out in the end what gets us is not climate change, it's the essentially natural resources or the lack of natural resources. So the collapse of any great civilization is always food and water, all right? And one way you can stave that off is that we waste an awful lot of energy and water raising beef and chicken, all right? And so I think the footprint is that we would use something like, I think is its largest, 70% less water and energy if we all became vegans, all right? And so, as most of the world already is, I think that's where we're all headed. Myself, I'm for it, yeah? I'm trying, actually.
Holly, are you a vegan?
I'm not a vegan, but I've been influenced by looking at these studies about these trade-offs, and my goal for my family has been to cut meat consumption by 80%. So I think that's maybe more realistic for a lot of people who have cultural values around meat or whatever. And I'm really excited to see companies like Memphis Meats and come out with kind of these new cultivated meat, clean meat products.
He's going to be giving a talk here at the Aquarium.
Oh, yeah. There you go.
This is meat grown in the laboratory. You start with some of the same ingredients that would be in a natural cow, and the flavor is the same. And some of the objections are that it's so realistic that it has blood, and that offends some of the people. Yeah. All right, Lynn, do you want to add anything to that?
No.
I'll add one thing, though. You said that your generation feels that they don't have any influence and can't have any impact on events, and I think that's a major cop-out, all right? Because any generation could have said that, all right? Yeah? Yeah. But I got out and I registered voters and I voted. And I voted every election I was ever in since 1960, all right?
And I just want to add to
Holly, go ahead.
the question. I mean, I don't think these consumer choice decisions are ultimately the main thing. If you look at a carbon basis, maybe trying to cut out flying is a big one. But I think that there's a lot of young person inspired groups out there, Sunrise Movement, Extinction Rebellion, the climate mobilization, really a lot that are influencing, discourse around the Green New Deal. And I think what we need to do is get civically engaged again and not abandon all of that civic infrastructure that's been set up during the past 3 centuries, because that's really kind of our most valuable thing.
Bill had pointed out that water will become one of the big issues, and in California, 70% of our developed water goes to agriculture, and a great deal of that goes to raising cattle. And so we're trying to urge shifting some of the protein production from the land to the ocean with sustainable aquaculture. It doesn't release any greenhouse gases the way cattle and pigs and chicken do. It doesn't use any fresh water except during the processing phase, and it's a heck of a lot better, healthier, more source of protein than beef. Chickens aren't so bad, actually. The cattle are far and away the worst. Pigs are second. Chickens are actually pretty good. Yes.
Aquaculture.
Aquaculture, yes, thank you.
The question is, it was asked earlier about how can citizens become advocacy for science. Well, attend seminars like this, attend the lectures at the aquarium, and
There are lectures here at the aquarium?
attend your academies.
We have a
Educate
lecture
yourself,
every week,
You
yeah.
automatically become a spokesman for science, and then get out and vote.
Who? Yes, go ahead. Right.
Is there some tipping point? I'm sorry. Is there some tipping point that determines that?
Get the microphone closer to your mouth.
Is there a tipping point that determines that? And like agriculture was just mentioned, and I've read things about methane being produced.
Right. Okay, so we hear about the 1.5 degrees Celsius aspirational goal from Paris and the 2 degrees Celsius cautionary. Is there a tipping point in all of this? Who wants to answer that? You were one of the authors of those reports. You got the Nobel Prize.
One many thousandth of a Nobel Prize, just like the Red Cross. So, one point, I'm not on that end of what the effects of it are. I'm more on the evidence for what is being. I'm on the measurement side and the prediction side, but not on the effects. So that's you guys.
Okay, if you want to know what the tipping point is, move to Pasadena or the Inland Empire and don't use your air conditioner next summer. And you'll know you're past the tipping point.
I'd say even in Solana Beach, we remodeled our house 5 years ago, and I said, no, we've got sea breeze. We can have natural flow. By this summer, I bought an air conditioner, and my contractor said I'm his case in point when he goes to build new houses for more people. Put in a HV, the whole system. Even in Solana Beach, it's unbearable in the summer, late summer.
Holly, do you want to add your candidate for the tipping point?
I think the tricky thing about the tipping points is we don't necessarily know what they are until we've crossed them.
That's right, till we cross them. And we may already have. It's right here in the front row.
What can we do when scientists speak? They always talk about science is always willing to accept that there's a better answer. I read an essay by Isaac Asimov 1 million years ago, and it was titled The Relativity of Wrong. Okay, and so it was eloquent about science adjusts things, not changes horribly very often. So how do we maybe stop talking about that aspect of science so people don't focus on the doubt? And then the innovation comment I heard passionately back here. Innovation is driven by making money or saving the world. More likely by making money. The legislation is how you make innovation pay. You legislate that the problem has to be solved, and you find a funding mechanism for it. If you can do that without legislation, you need to be in politics, you need to vote, and you need to run for office.
Legislation to stimulate innovation has to be very cautious that it specifies the problem but it does not specify the technology, because that freezes innovation, and we made that mistake with the Clean Water Act. But what about the other aspect of this, uncertainty? That's the nature of science. Who wants to address that?
Well, you know, one thing, talking about innovation, the thing that's driving renewable energy today, that means solar energy and wind energy, is not scientists or not environmentalists. What's driving it? The market, all right? It turns out that it's cheaper than oil, all right? And so a lot of the change we see, of course, positive and negative, will be driven by the market. And you know, I think that is the big driver.
But it's only cheaper because governments invested in the engineering and science at the basis of it. Yeah, so I think that government is super important. It isn't just laissez-faire out there. It would not be cheaper without that. Now it is, and it's excellent. And our political decisions to separate ourselves from external oil sources, I think that's been important in that legislation.
Holly, would you like to add anything? No. All right, we have one.
Yeah, first is a comment. The National Academies of Sciences sponsors a lecture series in Irvine called Distinctive Voices. They have a YouTube channel. One of the speakers in the last year, I think, is a climate scientist married to a evangelical who disbelieves all that stuff. And her talk was how to talk to these people. I suggest you look that up and learn from
it's online, yes, it's online.
And now my question is about how do we get people to look outside the box at the innovations that are possible that really solve it? I'm a physicist. Physicists have known for many years that if you can put solar panels outside the atmosphere, they're roughly 10 times better than on the ground. But there are problems with how do you get the energy down and around the world to where you want it and get out of the problems. I actually know a solution. I wrote a book about it called Avoiding the Extinction of Humanity, A Practical Plan. But getting the word out.
How do we encourage out-of-the-box thinking?
What?
How do we encourage out-of-the-box thinking? That's a very good question, because right now with the National Science Foundation, by and large, to get supported, you have to prove that you can successfully complete what you're proposing. That doesn't lead to dramatic out-of-the-box thinking. Lynn?
But National Science Foundation has the big idea competition right now. We're all sitting there going, okay, what big idea have we got? How many people can we get together? My husband has one. He's working with a guy at Caltech. So my husband's Scripps. You know, they're talking about just getting a whole lot of limestone and putting it in the ocean, and that'll suck down carbon dioxide. How about that? And how much money would that cost? How do you innovate that? So all these solutions. There is, private foundations are an amazing source of funding for this if you know how to get there.
Private foundations are probably more than the government. And if places like the X Prize, for example. Bill?
This is sort of off your topic, but people keep mentioning evangelicals as if it's something toxic, all right? Now, I have no problem at all talking with religious groups, all right? I find them as open as any other group. And in many ways, they're more important. You know, there are politicians, there are educators, there are scientists. But who do most of people in the world listen to? All right? They're spiritual leaders. And probably it's the most important group to get in touch with. And so I actually get kind of bored talking to scientists. It's like preaching to the choir. And so I actually search out speaking at various churches or synagogues or wherever, all right? And they're as open as anybody else, so.
And the very famous scientist E.O. Wilson wrote a wonderful little book about how creationism and religious leaders are going to play a key role in combating climate change. I want to, where's the microphone? Okay, go ahead.
Right here. Okay. I just, I'm concerned, and maybe there's something I'm missing here, but it's pretty consistent in Long Beach, whether it's our CAP program, where we're going to discuss how we deal with GHG emissions, or whether it's a project in our wetlands, moving a project. We don't talk about oil here. We don't talk about extraction of fossil fuels. Fossil fuels are the double F words in Long Beach, and I don't necessarily think it's part of this panel, but I'm just wondering why, or what you think when you talk about the contribution that people are making by having babies, all of it totally legitimate, the contribution of building in fire zones, the contribution of the kind of cars we drive. California extracts fossil fuel. This town, this state was the
biggest oil boom.
Anyway, bottom line is, like, we want to figure out how to leave it in the ground. So help us. How do we leave it in the ground?
Anybody want to respond? Leave it in the ground. All right, who hasn't had a chance to ask a question, who would like to? Yes. Wait till you get a microphone, please. This is being streamed live and they can't hear you.
Okay, thanks. Yeah, I'll wait for an answer.
I asked if anyone wanted to respond, and I didn't get any individual. Anybody want to respond, keeping it in the ground?
Yeah,
Holly?
well, a few things that have been significant. The divestment movement, I think, has had real impacts in raising awareness of kind of fossil fuels as a dangerous investment for companies and other institutional investors, pension funds, et cetera. I also think that the lawsuits that especially young people have been active in have also raised awareness of, as fossil fuels are increasingly being framed as a risky thing to invest in. And I think that's one avenue that has shown some promise. There's probably lots of other important avenues.
Bill, do you want to add?
No, I mean, this is just, I guess, part of the reason I didn't go very deeply into this in my talk is it's just so fundamental to what needs to be done. And, yeah.
Well, Long Beach was one in downtown LA, Signal Hill, one of the largest oil finds in the history of the United States in the 20th century. And the reason Long Beach looks so good is that they have a huge tax base from all those oil drillers. So, you know.
Okay.
Okay, let me also say this, is that Los Angeles is the largest urban oil field in the world, all right? And yeah, it's just huge. Yeah? There's 1/3 of everybody in Los Angeles County lives within a half a mile of an oil well, all right? It's huge, it's big business here. But so the bottom line is that Holly's mentioned a lot of positive things, but it's who you put on your local city council.
And I would just add, I think
it's how you vote.
I would agree with you that we need to, let's keep it in the ground, but that means then we have to develop diverse, robust portfolios of energy. And there is no single answer. If you look at the environmental damage that large solar farms do because of the amount of real estate they take up, because of very low energy density, we need diverse portfolios, and that's what we haven't been willing to embrace. Okay, let's see, right here we had one.
So I'm an indigenous person, and I work with a lot of the local tribes here. So I work with Tongva and Ahashiman people and Luiseño people. And so I know their history is California being like 90% genocide in the 1800s. And I was just listening to your speech, and I just wanted to add you know, that perspective that a lot of these fires have also been because we're not allowed to practice our spiritual ways. So that's why I was trying to talk to you about the difference in perspectives. And I think there's a lot to be learned from these people as well as my people. And I don't see that being discussed here, but maybe that's something you could explore. And I really have enjoyed all of your talks, so I'm sorry if I was disruptive. But I do want to mention, I know genocide is a powerful word, but a lot of the reason that these forests are burning so quickly is because Native people are not allowed to practice their ways. They do exist, and they still live on their land, and they would like to practice their ways. And some of that forest management, it should be maybe done in consultation with these people and the ways that you used to practice things, or still want to, because they've been maintaining these forests for thousands of years. And it was slow burning. They created deliberate meadows so that the forest could be stopped.
There's a great deal of what's called TEK, traditional ecological knowledge, among the Native Americans, and we often forget. Anybody want to, Bill, do you want to respond at all?
Yeah, let me say, you make a good point, because there are larger fires, they're fiercer for a number of reasons, but there are fewer fires. And the original people here, the Native Americans, they would normally burn more frequently in a more controlled way, and to renew the ecosystem, because these areas should burn every 20 to 30 years. It's better for the plants, better for the animals, all right? And so the real villain, of course, was who? Smokey the Bear, you know? Stop fighting forest fires, you know? So the real villain here, all right? But you make a good point. A lot of the native peoples.
Yes, we do. And right.
Yeah.
And one of the most important things we could do in California would be to curb the spread of people, and we should concentrate them in the villages and go vertical rather than horizontal, because one of the reasons these fires are so much more damaging, as Bill pointed out, we are building in areas outside of that, into the wildland areas, and that's a terrible mistake. We've had about time for two more. Who has one?
One more question, probably? Maybe two more, since mine is just a statement. I want to say I belong to 3 climate groups in Orange County, and join a group, please. There are so many options, and I belong to Citizens Climate Lobby. I'm the chapter chair of the Climate Reality Project, and I belong to OC Clean Power, which is advocating for community choice energy in Orange County. And by 2 years ago, I wasn't doing anything. But by doing that, I learn about if I want to be on a team, campaigning against oil, if I want to advocate for community choice energy, if I want to campaign for certain candidates. But if we all, remember in groups, you learn from each other and you learn what's going on. And so I just encourage you, if you're from Orange County, please talk to me afterwards. And I'd love to connect with anybody in Long Beach that's involved in those groups.
Okay, now Ron Stalk wants us, before we end, to have a question or two specifically about Long Beach. And I'm assuming you want it relative to sea level rise, probably. Is that right? So who has a question who has not asked a question? Okay, over here. It's going to be on sea level rise in Long Beach, right?
That's what I came for.
Good.
Could you, and I saw a lot of graphs and statistics. What is the sea level rise per year in Long Beach? Because it's a couple of feet from going over the seawall along Bayshore. So what number can I write down in my notebook and then do some math to see when to move out? What's the sea level rise per year?
The sea level rise in Long Beach today is 3.5 millimeters per year, which comes out to about 1 inch a decade. All right. Going back to the 1870s, the sea level rise in Long Beach has been a little over 8 inches. And some of the projections going out into the middle of the 21st and the end of the 21st century puts it anywhere between 4 and 6 feet. All right. 6 to 8 feet would put the Port of Los Angeles and the Port of Long Beach out of business. All right. Now, if you don't think that's not serious, 40% of the commerce in the United States from the Far East comes through those two ports. And so the whole economy of the United States is wrapped up into the port of Long Beach and the port of Los Angeles.
So let me come back to Long Beach. There's a program tomorrow put on by the city at 6 p.m. and it's going to be at the Best Western at Golden Sails on Pacific Coast Highway. In Long Beach, you have to distinguish between the intermittent short-term flooding, which is happening now with increasing frequency, and total permanent inundation, which is a function of sea level rise. My take on all of this is that those people who live on the peninsula or in Naples can probably accommodate a couple, maybe even 3 decades more of intermittent flooding that will get worse, but that over time, retreat is the only answer because the highest elevation on the peninsula is 7 feet. And right now, the only way that people are able to live there is trucking sand every day of the year back up. That's not a sustainable strategy. And you can argue you can put your house on stilts, and that will be suggested tomorrow, but you still have to get to your house, and you need services. So like facetiously, I tell people, if I owned a home on the peninsula, I would find my least favorite relative and sell it to them. Now, we're going to take one more comment, and then we're going to thank you all for coming, and you've had your hand up for a long time.
In regards to a response about visuals of the sea level rise, it's all open source data. I am now in environmental sciences and in geographic information sciences. The geographic information sciences, if you can find a young person who is taking those courses right now, they're available at USC and everything, you can ask for a map of your community to show exactly what it is. Now with the predictions and what Lynn was talking about Greenland, there have been tests done. The acceleration of sea level rise is very dramatic. I have created a map of the harbor area for communities from San Pedro all the way down to Seal Beach. And Seal Beach and a lot of areas of Long Beach, there's some serious implications. The Netherlands is an entirely bioengineered, human engineered city and country, designing wetlands, designing berms and all sorts of ingenious ways to keep the ocean away. All of the Netherlands is underwater.
Thank you. That's a very good closing comment.
But go tomorrow.
Please join me in thanking our distinguished panel, and thank you for your patience.